ಎಜುಕೇಷನ್ ಈಸ್ ದ ಬೆಸ್ಟ್ ವೆಲ್ತ್ ಫಾರ್ ಮೈಂಡ್. ಶಿಕ್ಷಣ ಪ್ರತಿ ವ್ಯಕ್ತಿಯಲ್ಲಿ ಪರಿಪೂರ್ಣತೆಯನ್ನು ತರುವಂಥದ್ದಾಗಿದೆ, ಜೀವನದಲ್ಲೂ ಮುನ್ನಡೆಸುವಂತಹ ಸಾಮರ್ಥ್ಯವನ್ನು ನೀಡುವಂಥದ್ದಾಗಿದೆ. ಒಬ್ಬ ಕವಿವಾಣಿಯಂತೆ, ಶ್ರಮವು ನಿನ್ನದೇ, ಸಮಯವೂ ನಿನ್ನದೇ, ಸಾಧಿಸುವ ಛಲವಿದ್ದರೆ ಪ್ರತಿಫಲ ಕೂಡ ನಿನ್ನದೇ. ಈ ಒಂದು ಸ್ಫೂರ್ತಿದಾಯಕ ಕವಿವಾಣಿಯೊಂದಿಗೆ ಇವತ್ತಿನ ಈ ಕಾರ್ಯಕ್ರಮವನ್ನು ಪ್ರಾರಂಭ ಮಾಡೋಣ. ಎಲ್ಲರಿಗೂ ಶುಭೋದಯ. ನನ್ನ ಹೆಸರು ದೀಪ್ತಿ, ಸಹಾಯಕ ಪ್ರಾಧ್ಯಾಪಕಿ, ಗಣಕತಂತ್ರ ವಿಭಾಗ. ಮೊದಲಿಗೆ ಇಲ್ಲಿ ನೆರೆದಿರ್ತಕ್ಕಂತಹ ಎಲ್ಲ ಗಣ್ಯರು, ಅತಿಥಿಗಳು ಹಾಗೂ ನನ್ನ ಸಹೋದ್ಯೋಗಿಗಳಿಗೆ ಸ್ವಾಗತ, ಸುಸ್ವಾಗತ. ನಮ್ಮೆಲ್ಲರಿಗೂ ತಿಳಿದಿರುವ ಹಾಗೆ AICTE ಅಖಿಲ ಭಾರತ ತಾಂತ್ರಿಕ ಶಿಕ್ಷಣ ಪರಿಷತ್ತು ಇದು ಭಾರತದ ತಾಂತ್ರಿಕ ಶಿಕ್ಷಣ ಹಾಗೂ ನಿರ್ವಹಣಾ ಸಂಸ್ಥೆಯಾಗಿದ್ದು, ಶಿಕ್ಷಣ ವ್ಯವಸ್ಥೆಯ ಸರಿಯಾದ ಯೋಜನೆ ಹಾಗೂ ಸಂಘಟಿತ ಅಭಿವೃದ್ಧಿಗಾಗಿ ಇರುವಂತಹ ಏಕೈಕ ಸಂಸ್ಥೆಯಾಗಿದೆ. AICTE ವಾಣಿ ಇದು ಭಾರತದ ಭಾಷೆಗಳ ಪ್ರಗತಿ ಮತ್ತು ಪೋಷಣೆಗಾಗಿ AICTEಯ ವತಿಯಿಂದ ಹಮ್ಮಿಕೊಂಡಿರುವಂತಹ ಯೋಜನೆಯಾಗಿದ್ದು, ಇದರ ಅಡಿಯಲ್ಲಿ 22 ಭಾರತೀಯ ಭಾಷೆಗಳಲ್ಲಿ ನಮ್ಮ ಅತ್ಯಾಧುನಿಕ ತಂತ್ರಜ್ಞಾನ ಹಾಗೂ ವಿಚಾರಗಳನ್ನು ನಮ್ಮ ಮಾತೃಭಾಷೆಯಲ್ಲಿ ಕಲಿಯುವಂತಹ ಅವಕಾಶವನ್ನು ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮ ನಮಗೆಲ್ಲರಿಗೂ ಕಲ್ಪಿಸಿಕೊಡುವಂಥದ್ದು. ಇದರ ಈ ಪ್ರತಿಷ್ಠಿತ AICTE ವಾಣಿ ಉಪಕ್ರಮದ ಅಡಿಯಲ್ಲಿ ಈ ಒಂದು ಕಾರ್ಯಾಗಾರವನ್ನು ಆಯೋಜನೆ ಮಾಡಲಾಗಿದ್ದು, ನಮ್ಮೆಲ್ಲರಿಗೂ ನಿಜಕ್ಕೂ ಹೆಮ್ಮೆಯ ಸಂಗತಿಯಾಗಿದೆ. ಬನ್ನಿ, ಕಾರ್ಯಕ್ರಮವನ್ನು ತಡ ಮಾಡದೆ ಆರಂಭ ಮಾಡೋಣ. ನನ್ನ ಸಹೋದ್ಯೋಗಿ ಶ್ರೀಮತಿ ಸ್ಮಿತಾ ಅವರೊಂದಿಗೆ.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ, ಶುಭೋದಯ. A very good morning to one and all present here. I am Smita SP, Assistant Professor, Presidency School of Computer Science and Engineering. I am truly delighted and honored to be your host for today's AICTE Atal Vaani workshop on application of artificial intelligence in medical image processing and data science. It's indeed a proud moment for all of us at Presidency University to organize this workshop under the prestigious Vaani initiative of AICTE in association with the Presidency School of Computer Science and Engineering and the Presidency School of Information Science. Now, I kindly request Dr. Zafar Ali Khan N, Professor and HOD, CAI, ISC and RAI to escort the dignitaries to the dais. असतोमा सद्गमय, तमसोमा ज्योतिर्गमय, मृत्योमा अमृतंगमय.
ಅರ್ಥಾತ್ ಅಸತ್ಯದಿಂದ ಸತ್ಯದೆಡೆಗೆ, ಕತ್ತಲೆಯಿಂದ ಬೆಳಕಿನೆಡೆಗೆ, ಸಾವಿನಿಂದ ಅಮೃತತ್ವಕ್ಕೆ ನಮ್ಮನ್ನು ಕರೆದುಕೊಂಡು ಹೋಗು ಎಂದರ್ಥ.
This powerful verse from the Upanishad translates to lead me from untruth to truth, from darkness to light, from mortality to immortality. This timeless prayer reflects the journey of human consciousness, from ignorance to knowledge, from confusion to clarity, and from limitation to liberation. In Indian tradition, the lighting of the lamp marks the dispersal of darkness and the invocation of knowledge, positivity, and spiritual energy. It symbolizes purity, clarity, and the removal of obstacles before commencing any auspicious occasion or intellectual pursuit. To begin this auspicious occasion on a positive and enlightening note, I request all the dignitaries on the dais to kindly step forward for the lamp lighting ceremony, symbolizing the dispelling of darkness and the illumination of knowledge.
I'm very happy that all our events are actively engaged in all the seminar hall. That's one positive note. So I think I'm really proud to be part of this event. Definitely, I think I wanted to appreciate Dr. Zafar and all the organizing team members for wonderfully organizing this wonderful event. I think definitely this is event of this nature, especially application of AI in medical imaging and data science is one of the very important requirement at this point of the time. Since AI is entered into every field, like from gaming to trading to including treatment plant. You see in civil engineering, the wastewater treatment plant is also involved with AI. I think understanding the AI application and various open source tool, what I seen in the schedule is a lot of coverage on more practical aspect is covered as part of this event. I would sincerely request all of you to make use of this great opportunity to learn from the experts. I think there is a very good number of experts from industry. I think I also gone through the program Vaani. I think it's one of the great initiative from AICTE and Government of India, where some of the latest technologies is taught in the maybe how to be considered in the local language. That's one of the initiative of Vaani from AICTE, is one of the wonderful initiative. I think having said that, how AI is going to change the entire education spectrum is definitely one of the need of the hour, which every one of us should contribute when we teach to our students, especially when we teach any subject. How the AI is going to have major impact on the given subject is definitely one of the things which we all of us should cover. So I think I once again wanted to appreciate the Computer Science Engineering School and Information Science for taking this wonderful initiative. I think they have made a lot of FDPs in this summer vacation. Even I understand every day there is what new FDP is getting inaugurated. Even Monday there is another FDP starting. So I wanted to appreciate the entire team of Presidency School of Computer Engineering and Information Science. If you look at just 2 weeks before, we had a IEEE conference again organized by the Computer Science School, where ISRO chairman was chief guest. You can see a lot of activity which is happening at the Presidency School of Computer Science Engineering and Information Science. I once again wanted to appreciate the whole team from Presidency School of Computer Engineering and Information Science, especially Zafar for taking such an initiative. I sincerely request all the faculty members who are going to be part of this wonderful FDP to make use of this wonderful opportunity in full-fledged way, attend the sessions fully. I think I don't want anybody to miss any sessions in between going and coming. I think this FDP should be taken in a full sense. Please take it in a complete interest and understanding. So once again, I wanted to wish you all the best. Have 7 days of wonderful learning. I once again wanted to appreciate the team for organizing such a great event. Thank you very much.
ಧನ್ಯವಾದಗಳು ಸರ್. ಈಗ ವೇದಿಕೆಯ ಮೇಲೆ ಬರಮಾಡಿಕೊಳ್ಳೋಣ ಮುಖ್ಯಸ್ಥರು ಗಣಕತಂತ್ರ ವಿಭಾಗ ಡಾಕ್ಟರ್ ದೊರೈ ಪಾಂಡಿಯನ್ ಎನ್ ಅವರು ತಮ್ಮೆಲ್ಲರನ್ನು ಉದ್ದೇಶಿಸಿ ತಮ್ಮ ಸ್ವಾಗತ ಭಾಷಣವನ್ನು ಮಂಡಿಸಲಿಕ್ಕೆ ಬರ್ತಿದ್ದಾರೆ. ವೆಲ್ಕಮ್ ಸರ್.
So good morning to all of you. Respected chief guest for the day, Dr. Nagaraj from Central University of Karnataka. Respected Pro Vice Chancellor, Dr. Shivavirmal. Respected HODs, my fellow faculty members and participants from other colleges. So it's my great privilege to stand before you to say a few words on the occasion of the inaugural session of 3 days workshop on application of artificial intelligence in medical image processing and data science. So first of all, on behalf of the organizing committee, management, staff and students of School of Computer Engineering, first I'd like to welcome Dr. Nagaraj for this inaugural session. See, I have gone through this LinkedIn profile as well as Google Scholar report and has published a lot of publications, and one of his publications has more citations, around more than 250 citations. When a paper is getting more citation, that means it is of quality work. So I'm happy to see such a person who has done a lot of work in the same area. That is another important point. He has done a lot of work in the same area, and he is part of this program. I'm happy for that, and he is also going to give the keynote address. So I like to welcome on behalf of the organizing committee, sir, please. Similarly, I like to welcome our Pro VC sir, Dr. Shivaperumal, who is brain behind all our activities. Right? Whenever we go for help, immediately he will respond to us and he will say yes. From his, he will not say no to any of our requests. So because of it, we are able to do a lot of activities. So on behalf of the organizing committee, I like to thank and welcome him for this particular session. Welcome you, sir. So at this point of time, it's as Dean of the School of Computer Science Engineering, I like to appreciate the efforts taken by the team led by the convener, Dr. Zafar Ali Khan, then advisory committee, Dr. Mohammadi, Dr. Shashidhar, Dr. Murali Parameswaran, Dr. Swati Sharma, and the coordinator, Dr. Sivaramakrishnan S, and committee member, Ms. Mita, for their continuous efforts in making this program a successful one. Right? That too, it is sponsored by AICTE, 2 lakh, so it is sponsored by AICTE. I am happy at this point of time. I like to thank AICTE for sanctioning fund for running this workshop. Right? So I want the team to continue the efforts so that in future they will be continuing a lot of such workshop and FDPs so that the faculty members as well as students are beneficiary out of all these programs. Right? And my dear participants, whether the outside participants or local participants, our faculty members, please ensure that, as our PVC said, try to attend that 3 days workshop full, right? Don't go in between. No, don't miss any of the sessions. Remember this, the team, organizing team, they have arranged more than, they arranged very good speakers. I think I have seen some 6 or 7 speakers from outside. So, who are all renowned person in their own field. Definitely the sessions are going to be interesting. So, don't miss any of the session. And similarly, be collaborative with fellow researchers. Many of the people who are working in the same area, they are going to attend the program. They are attending the program. So, please make attempts to get collaboration with them. And similarly, try to ask questions. Right? That is more important because the resource persons are coming here not to just to deliver, just to deliver the seminar, but they are ready to answer your questions also. Any of your doubts can be very much cleared by them. So please ask questions and similarly explore the opportunity, whatever the new ideas you are going to get from this workshop, please try to implement that. Try to use those knowledge, whatever the knowledge you are going to gain from this workshop, use it for the next few years or few months, so that you are able to publish a paper or you are able to apply for a funded project. So that is the outcome of this particular workshop, right? See, now we are following outcome-based education. So that means whatever the activities we are doing, we need to fix the outcome for this. Similarly, for the workshop, what outcome we have fixed is, based on this workshop, whether it is this knowledge is going to be used in the class or they are going to use it for doing some experimentation work and doing some publication, or you have to make a funded project proposal. So in case if you are able to do things, the real purpose of this, the real objective of this workshop is met. We will be happy if you are able to communicate back that you have done something on using the knowledge gained by this workshop. So with these few words, I like to thank the organizing committee for giving me a chance to speak before the audience, before this August gathering. And I hope these 3 days will be more beneficial to you. And it will be, I think, the 3 days, your 3 days stay in Presidency University will be a memorable one also. Thank you very much.
Thank you, sir, for your warm and inspiring welcome. Now, I invite our convener, Dr. Zafar Ali Khan N, Professor and HOD, to kindly brief the gathering about AICTE Atal Vaani workshop, its objectives and the vision behind this initiative. So,
thank you, ma'am. Ellariku namaskaram. Very good morning to all. Myself, Dr. Zafar Ali Khan. Respected dignitaries, resource persons, faculty members, and my dear participants, external and internal members. Very good morning to all. On behalf of School of Computer Science Engineering, it's my immense pleasure to warmly welcome you all for this AICTE Vaani 3 days workshop. This 3-day workshop marks a significant step towards democratizing technical knowledge, enabling faculty members, research scholars, students across Karnataka, cutting-edge technology in AI through the language they are most comfortable with, through a blend of insightful sessions, hands-on training, real-world cases. This workshop's aim is to empower the participants on the potential of AI for the societal well-being, particularly in healthcare in AI. We are honored to join the distinguished speakers from academia and industries from Central University, Rakuten, Fujitsu, and Siemens. Those contributions undoubtedly inspired innovative thinking and practical applications. I also thank the AICTE Atal Vaani Academy for their generous support and promoting the regional language outreach in technical education. I extend my best wishes for the fruitful and enriching experience and hope that this platform sparks new ideas, collaborations, and deeper appreciations for AI role in transforming their lives. Welcome you once again. Let us make this workshop a grand success together. Thank you.
Thank you, sir, for setting the context for this workshop. It is with great pride that I now welcome our distinguished resource person for the day, Dr. Nagaraj Emanakanavar, Assistant Professor at the Central University of Karnataka. Dr. Nagaraj holds a PhD from National Institute of Technology, Karnataka, Surathkal, in Electronics and Communication Engineering. He has pursued his MTech in Digital Signal Processing and BE in ECE with a total postdoctoral and vast teaching experience and research. His contributions to signal processing, medical image processing, computer vision, deep learning, and artificial intelligence are noteworthy. He has worked as a research staff member at Tokyo Institute of Technology, Japan, and completed a postdoctoral fellowship at Chosun University, South Korea. His extensive list of publications, awards, and recognitions, most notably the Best Paper Award for his work on attention-based MSegnet architecture for brain MRI, are a testament to his excellence in the field. We are truly honored to have him with us today to share his insights and expertise. We welcome you, sir.
This workshop, aligned with Vaani vision, explores the timely and impactful theme, application of artificial intelligence in medical image processing and data science. In today's era of digital healthcare transformation, AI has emerged as a game changer in diagnosing, analyzing, and interpreting complex medical data. The integration of AI into medical imaging and data science not only augments clinical decision making but also contributes to early diagnosis, personalized medicine, and overall improvement in healthcare outcomes.
Thank you and wishing you all a fruitful and intellectually stimulating workshop ahead. Now I would request Dr. Shivaram Krishnan sir to deliver vote of thanks.
So, a warm welcome to all the dignitaries on the dais and off the dais. So, I'm standing here with great privilege to welcome Honorable Chancellor Dr. Nisar Ahmed sir for providing such a great infrastructure to conduct such an event. Next, I'd like to thank Honorable Vice Chancellor Dr. Thiruvengadam sir for being with a lot of moral support. With the support we could able to take this event. Next, I'd like to thank our Pro VC, Dr. Shivaparmal sir. So from the day one when I got that sanction, I went to sir. From that day till yesterday, he was following us throughout the event, and he was providing a lot of support to us. So I thank you so much, sir. And next, I'd like to thank our Honorable Pro Vice Chancellor Dr. Vidya Shetty ma'am and Dr. Samira Noor Akbar ma'am, Registrar of our college. And I'd like to express my thanks to Dr. Durai Pandian sir. We also met Durai Pandian sir last week, and he was having a lot of vision to take this university to great heights. So definitely sir, this is a starting point, and we'll assure you that many such events will be organized. So I welcome you sir, and I thank you for all your support. And I like to thank my HOD, the convener of this event, Dr. Jafar Ali Khan sir. So from the day one till today, we want to coordinate with so much people, and that is definitely possible with your support sir. So thank you so much for your support. And I also like to thank our faculty coordinator, Ms. Smita ma'am and Ms. Deepthi ma'am for the necessary support and being such a nice MC. And I also like to thank the student coordinator in Sujana, and for small work and for making all those brochures. Okay, she helped me a lot. So in his absence, I also like to thank her. And finally, this event is more successful only with the vibrant participants. Without your presence, no, we can't able to organize such a great event. So I like to thank all the external participants and obviously the internal participants and my fellow colleagues. And with your support only, we could able to make this event a grand success. So once again, I thank you all for making this event a grand success. Thank you.
ಥ್ಯಾಂಕ್ ಯು ಸರ್. ಜೀವನದಲ್ಲಿ ಗುರಿ ಇರಲಿ, ಗುರಿ ತಲುಪುವ ಮನ ಇರಲಿ, ಮನದ ಜೊತೆ ಛಲ ಇರಲಿ, ಛಲದ ಜೊತೆ ಗುರುವಿನ ಆಶೀರ್ವಾದ ಸದಾ ಇರಲಿ, ಗುರಿ ತಲುಪಿದ ನಂತರವೂ ಗುರುವಿನ ನೆನಪು ಸದಾ ಇರಲಿ. ಈ ಒಂದು ನುಡಿಮುತ್ತಿನೊಂದಿಗೆ ಈ ಒಂದು ಉದ್ಘಾಟನಾ ಸಮಾರಂಭಕ್ಕೆ ಆಗಮಿಸಿರ್ತಕ್ಕಂಥ ತಮ್ಮೆಲ್ಲರಿಗೂ ಮತ್ತೊಮ್ಮೆ ಹೃದಯಪೂರ್ವಕ ವಂದನೆಗಳನ್ನು ಅರ್ಪಿಸ್ತಾ ಇದ್ದೀನಿ. ಥ್ಯಾಂಕ್ ಯು ಸೊ ಮಚ್.
Thank you all. Now I kindly request Dr. Zafar sir to escort the dignitaries of the dais.
Okay, so I welcome all the external and internal participants. So already we gave the introduction about Dr. Nagaraj sir. I personally know Dr. Nagaraj sir from 2018, and sir has done two postdocs. He has traveled to Japan and South Korea, and his field of interest was image processing. PhD also is from the same topic. So definitely will have a very good deeper insight about it, especially for the research scholars. I definitely agree that will be of great help. So morning, first off, they will be giving an introductory session about machine learning, and then after we have one more speaker. He is from industry. He is going to touch upon image processing, and then afternoon session again sir will take the last session. That session will be fully unseen. And nowadays you all know that we have the benefit of AI. So within 2 lines of prompt will be getting the entire thing. So instead of going to that, first we'll elaborate technically what it has to be done with the help of the IT. And finally, for your benefit, last 20 minutes he is going to tell okay how we can able to achieve the same thing in Google collaboration in a short. Over to you.
Hello. Sir, audible. So, good morning to everyone. My name is Akash. Presently, I am working in Central University of Karnataka as assistant professor in Electronics and Communication Department. So today I am going to present based on deep learning based medical instrumentation using the convolution neural network. So first for 20 minutes I will explain about a little bit about machine learning. What is the difference between artificial intelligence, machine learning and deep learning, and some of the techniques we are using in machine learning. We will discuss in within 20 minutes. After that, I will move on to medical image processing. That is medical image processing using convolution neural networks. So, first of all, can anyone know what is the difference between AI, ML, and DL? Artificial intelligence, machine learning, and deep learning. And what is artificial intelligence?
Let's take it.
What?
Training and
Training on object. Yes. Other answers. So the artificial intelligence is nothing but we are creating a machine which enables, like, it will learn, behave like humans. It will enable the machine to behave like humans. For example, robotics. Robotics, what we are doing? In robotics, we are having some. So in robotics, we'll have a intelligent machines. Intelligence is having it will do what the human will do. So in robotics, we are having a machine. That machine will be trained on some machine learning algorithms. Okay. So that is what is the AI is nothing but which enables the machines to think. That is artificial intelligence. What is machine learning? What is machine learning? That is a statistical tool mainly used for analyzing the data. So, for example, if computer is there, so for doing like in a machine to do work, we are feeding some data. The data will be processing inside the machine, and it will give some output. So the machine learning is nothing but is a statistical tool mainly used for data analysis and exploration. And also, machine learning is a subset of AI. Usually, it is a subset of AI. What is deep learning? Deep learning is a subset of ML. So first, AI will be there, artificial intelligence. After that, so this is the AI, and ML is the subset of AI, and deep learning is the subset of ML. So what is data science? Data science combines all these elements. Data science combines all these elements using some statistical models and optimization algorithm. We are using all these, it is combining all AI, ML and DL, that we call as DS. AI is nothing but it is a machine. We are creating one machine which will mimic like a human. Machine learning is the subset of AI. It uses some statistical tools for data analysis. Deep learning is the subset of ML. And here we are using some neural. It is deep learning is connected with some neural networks. It uses some millions of neurons, and it will predict the outputs. Based on the data we are getting, it will predict the outputs. So mainly in deep learning we are using artificial neural network. The category will be there. There are different classifications will be there in deep learning. That is artificial neural network, convolution neural network, and recurrent neural network. So in this topic we are focusing on convolution neural networks. And also machine learning will have different classifications. There are main classifications are supervised learning, unsupervised learning, and reinforcement learning. Okay, so now let us start with the topic. So as I told, the difference between artificial intelligence, machine learning, and deep learning and data science. So the artificial intelligence means creating smart machine to mimic human behavior. Deep learning, the machine learning is nothing but subset of AI and builds a model based on training data to make predictions. Basically, statistical tools. Here we are using some algorithms to train the data. So it is a statistical tool mainly used for data analysis. So deep learning is a subset of machine learning, a class of machine learning algorithm to solve complex problems. So in deep learning, we are having different categories, that is artificial neural network, convolutional neural network, and recurrent neural network. And data science combines all these topics like machine learning, deep learning, and artificial intelligence. So nowadays in research, the most of the people they are moving from machine learning to deep learning. Why? Competition. Increase accuracy. One point is that increase accuracy, and machine learning.
But the data set size is too small, I can apply the machine learning techniques effectively.
Yes,
If
yes.
the data size is increasing in the volume,
Yes.
then machine learning seems to be little backward. So I have to apply the deep learning.
Yes, ma'am. So machine learning. So if you are having a data set more, if you are having a data set more, so the machine learning takes more computational complexity, and also it makes like it will go under overfitting conditions. So nowadays the data is more. So to get more accuracy and minimum computational complexity, the people are moving from traditional machine learning algorithms to deep learning algorithms. So as I told, the machine learning will have three classification, that is supervised learning and unsupervised learning, and also one more is there, reinforcement learning. So in this we are not discussing reinforcement. Little bit we are discussing about supervised and unsupervised learning. So the supervised learning means we will have some labeled data. So initially we know what is the output, what is the labeled data. We call it as labeled data. Initially we know the labeled data. Unsupervised learning means we don't know that unlabeled data. So we'll discuss in these slides. And again, supervised learning, it is classified as regression as well as classification. Regression means we are predicting only the value, that is quantity. It is having value or quantity. What is classification means it is categorical. Yes or no, 0 or 1, true or false. Like that, we are classifying the object or data. So, for example, supervised learning. Let us just consider this example. Here, the child is playing with some several toys. So, we want to categorize. We want to distinguish between the based on color or based on type of the object. We have to put into these boxes. For example, you are having three classes, three baskets. The first basket will have only the girl toy, and the second basket will have a car, and third basket will have a lorry. So we want to categorize. These are the labels. Usually we get these labels. So supervised learning means we are having, initially we know the output, we know the labels. So that is the girl toy, car and lorry. These are the labels. So based on this, we have to categorize it. So we can easily put into wherever the toy is, a girl toy is there, we can put into that basket. and wherever the car is there, you can put into that car basket, and lorry you can easily classify it. So that is nothing but supervised learning. In unsupervised learning, we don't have any labels. Just they will give the empty boxes here. So we want to predict. We want to put into these toys into these boxes. So how can you make it? Based on the colors. For example, based on the colors. Here they have categorized into white color, that is red one color, and blue one color. Based on the toy objects, they have categorized. So in supervised learning, based on the clusters, cluster means based on the texture, color, based on the object size, based on these features, we are categorizing the classes. So the difference between supervised and unsupervised is, so the supervised will have labeled data, unsupervised will have, and it doesn't have any label. So the output, initially we know the output in the supervised learning, and unsupervised learning we don't have any, we don't know the output. So the main rule is to predict outcome. Here find the patterns, clusters, and structures. Common classification algorithm. So here the supervised learning mainly we are discussing classification and regression. As we know, regression is it will predict the value or single value. It will predict the single value. And classification, it will tell about yes or no, 0 or 1, based on category, it is categorization. And here unsupervised learning, we are using clustering, association, gradation algorithm, and accuracy measurements. These are the evaluation metrics we are using. That is accuracy, accuracy, precision, and recall we are using in supervised learning. And in unsupervised learning, it is uses skill object and skill object score. Okay, and complexity. Typically, simpler and simpler to evaluate the supervised learning by because we know the initial output. That's why it is simpler. It is little bit complex. Why? Because we don't know the what is the output thing. So that is the difference in unsupervised learning. So here we are discussing only supervised learning, like because since we it is like it will be simpler. And the main course is about this supervised learning. So here you are not able to see this. Okay. So what is regression? Regression means, so as I told, it is continuous. We are predicting the value. That is continuous value. For example, so I want to purchase a plot. So what are the features we are looking? Plot or buy home. Let us consider buying house. So what are the kinds we are looking? What are the features we are looking? We are looking what is the area of the square feet. Area. What is the size? That is area means what is the size? How many bedrooms will be there? And what is the price? The structure, everything. These are the features we are looking. So based on that, what we are predicting here? What is the price? What is the price? So in this, so it is having area, bedroom, and city. City also, these are the features. These features we are giving to the machine learning model. We are predicting one value. One value, that is price. For example, another example. So here, so we are predicting the car price. So it is where the features what we are giving is mileage, that is 20 km per hour, and what is the company name, that is Toyota, and what is the model, that can be. So these are the features. Based on this, we are predicting one price. So regression is nothing but based on given features, we are predicting one value. That should be continuous. And classification, it is, as I told, it is 0 or 1, dog or cat, true or false, yes or no. So we are predicting two classes. It is not like binary classes, multi classes will be there, multi classes also it will be there. So the classification will have two, it is like categorical. It is like categorical, that is 0 or 1. So as in classification, basically these are the data. For example, in transaction, you want to identify that fraud transaction or non-fraud transaction. So what are the features? We are having these vendor, account, location, and time. These are the features. What is the target value? Yes or no? The transaction happened it is a fraud transaction or non-fraud transaction. That is yes or no. These are the labels. First, we'll have a data. We'll have a data like this. So these data will be trained on the model. Trained on the model. Model will be like anything. In machine learning, we are using algorithm. We are using SVM, neural network, random models. These are the algorithms. We are training on that model. We are getting one trained model. We are getting one trained model. So when the test image, here test image, it doesn't have any label. Yes or no? When the test image, if you are giving, we should predict the fraud transaction or non-fraud transaction. So that is classification. Supervised learning classification. That is binary classification. In multiple classification, you will have different type. Based on this magazine, it should be predict what kind, business magazine, sports or technology, and health. Based on that, you will have 4 types of classification or 5 types. Like different types of classification we call as, more than 2 we call as multi-class classification. So what is the differences between logistic and regression is? So regression, the problem will be continuous output. It should be continuous, that is single value. And logistic will be categorical output, that is yes or no. Have multi-class classification also. It will come in logistic regression. And it should be real number. The output should be real number. It is probability 0 or 1, yes or no, like that. And equation form like linear equation. Here we are using sigmoid of linear equations. So in linear equation, usually what we are doing, for example, predicting the price of a house. So here we will have a features. For example, area which we are giving, we are predicting price here. Okay, these are the, for example, if you are considering this is the data. So based on this area, we are predicting the price. So what kind of, how we are predicting? We start with, based on the straight line. Straight line, we are drawing the straight line such a way that all these data should be fitted. For example, if the line if we are taking like this, so that it will start from, for example, if it will start from here, so the data points will be more distance here. It will be larger distance. So if you are taking initial point here, it will be like an iterative process. So it will search a straight line such a way that all the data points should be fitted, which means we are minimizing the error between these points. That will be linear regression. So I will explain in detail when we are doing the hands-on section. So here, usually the line equation will be what? Mx plus c. C is nothing but a constant term we call as bias or intercept. What is x? X is the feature. Here feature is what is the feature here? Area. This is the area. What is the output here? Y. Y is the price. We are predicting the price. What is the n here? And is the slope. It is the slope. What is the slope? What do you mean by slope? So the slope between 2 points, you can bring this slope. So the slope y, that is n is nothing but y2 minus y1 by x2 minus x1. If the line is horizontal, what is the slope? The slope will be 0. If the line is vertical, what is the slope? Not defined. It will be not defined. So why? Because here y2 will be 0 here. The same value. For example, you can see if it is having, so y2 minus y1 will be 3 minus 3. It will be 0. If it is horizontal, if it is vertical, below the denominator will become 0. So anything by 0 will be undefined. Okay, this is linear equation. The logistic regression uses sigmoid of linear equation. It is similar to linear only, but it will tell suppose it will classify 0 or 1 or yes or no, like that it will do. Binary, like sigmoid classification mainly used for binary classification. Only two, if you are having two classes, the mostly we are using sigmoid. If you are having more than two, usually we use softmax classification. Multi-class classification we are using, that is softmax for multi-class classification and binary for sigmoid classification. The loss function we are using mean squared error, here cross boundary. The algorithm is gradient descent, here maximum likelihood or gradient descent. And example target of salary, predicting the price, predicting the age. These are continuous values. We are getting only one value. That is linear regression. Logistic means fraud detection, spam, loan, personal. These are all spam, not spam. These are also two classes. So that is logistic regression. So these are the machine learning different classifications. There is supervised and unsupervised learning. So before going to deep learning, let us talk about what is artificial neural network. This artificial neural network also is one type of deep learning technique. So the people, they started with artificial neural networks, then they moved to convolutional neural networks. Why? Because the artificial neural network has some drawbacks. So to overcome that, they are using convolutional neural network. Yes.
So I have a doubt. In logistic regression, we get some value between 0 and 1, right?
No, real value we get, integer value. It can be like usually in decimal, like in a float, like floating float value you get.
You mentioned class or how is it different from classification?
Plus 0 or 1 classification. Like I told, dog or cat. These are two classes. In classification, usually you will have two classes, 0 or 1, true or false, or yes or no, like that. Labeled data will be there.
So can we say it is a special type of classification, logistic regression?
We can say that special type of classification. Logistic regression will have different names. Binary classification also we call it as. So what is artificial neural network? Artificial neural network is nothing but, so it is inspired from the human brain. So as we know, the human brain will have how many neurons in the brain? There are 10 raised to 10, almost 10 raised to 10. It is almost millions neurons will be there. Based on the neurons, the function of neurons, they have created artificial neural network. So as we know, in brain we will have different types of the neuron will transform information from one neuron to another neuron. So like the synapses and dendrites, it will receive these information. It will send to the cell body. The cell body will process that information. Through axon, it will send to the another neuron. So based on this information, they have made an artificial neural network. So the cell represents a neuron or node. The cell represents neuron, and dendroid and synapses is nothing but weights. These are the weights. And the cell body represents net input. The cell body is represents net input, and axon is the output. This axon is the output. So usually when the cell body, what cell body in the artificial neural is net input. So these are the features. Each feature will have a associated weights. So it will multiply these weights, and all the features along with the associated weight will be multiplied and summed up here. That is the net input. That net input is given to an activation function. So that will predict the output. That will predict the output. So how artificial neural network works means it is having two propagation, that is forward propagation and backward propagation. Usually, for example, simple example, x1, x2 are the inputs. We are feeding it a neuron. We are getting the output, that is y hat. That will be written as, that is a predicted value. So inside the net input, what will happen? So the W transpose into X. W transpose, the W is the weight, X is the input, and we are adding the bias. That will be the Z. That is the net input. The net input is given to an activation function. The activation, we are having different types of activation functions. Like we are discussing sigmoid. Sigmoid is the one activation function. We'll have tannage, we'll have ReLU, leaky ReLU. These are the different types of activation functions. What they will do? It will, for example, if you are considering sigmoid, the values having negative value, it will classify it as 0 or -1. The value which are positive values, it will classify it as 1. So these are the activation functions. After summing all the input associated weights, we will get the sum input that will be passed to the activation function. The activation function will give the output, the predicted output. So that is forward propagation. In backward propagation, what we will do, we will take the differentiation with respect to weights, bias, and some input. For example, here, whatever the output, that is the predicted value and the actual value, we are comparing in the end of the forward propagation. So we will have the predicted value will be the y dash, that is A. Actual value will be the y. As I told, the actual value is nothing but a labeled value. The labeled value is compared with the predicted value. Based on the compared this, we are taking the error. What is the error between these? That is, we call that mean square error or loss function. We can say. So that error will be calculated. If the error is more, then we have to train it again. Like we have to go to back propagation by differentiating with respect to sigma, with respect to z, with respect to w, with respect to b. Again, we are getting the updated weights. Again, we are feeding. Again, we are getting one value. And if error is more, still it is more. Again, we are feeding back. Again, we are getting different weights. Again, move on till the error should be minimized. That will be done in forward and backward propagation. Usually in neural network it works like this. So what is in artificial neural network may be used for these data series and a small set of data, like handwritten digit recognition, 2, 1, 3, 4 like that. So it is small images. Usually the small images, the resolution of the images it is small. Then they will use for artificial neural network. It will give you better results. So how they are using is, first they will convert this 2-dimensional array to 1-dimensional array, 1D array, and each pixel in the image it will work it as a node or neuron. We call it as neuron. These are the features. So these features, each neuron is connected to another neuron, that hidden layer of the neurons. each neuron is connected to every nodes in the hidden layer. And again, if you are having, for example, this image size is 7 cross 7, so you are getting 49 features here. So in first node, the 49 in 49, we are getting 2400 learning parameters. We get 2400 learning parameters. The hidden layer is connected to the output layer of the neurons. So here the 10 we are classifying the digits, like the 10 values will be there, 0 to 10. So the 49 into 10. So from hidden layer to the output layer, we are getting 49 into 10. That is 490 learnable parameters we get. So it is very less learnable parameters. Then that's why we can use artificial neural. For example, if you are having the resolution size is having more than 1000. So if it is 1000 cross 1000, the image size will be 3 million. The resolution of the image will be 3 million. So if you feed into this neural network, so in hidden layer, for example, if you are having 1000 hidden layers, so the learnable parameter is getting 3 billions, more than 3 billions. So the computation complexity will be increases. So to avoid that, what the people they are doing means they are using convolutional neural networks. What is convolutional neural network? They are not using these. They are not taking every pixel with a node here. They are using some convolution filters. So what they are doing means, so these are the disadvantages of using artificial neural network. That is too much computation because the learnable parameter will be more and treat local pixels same as pixels far apart and sensitive to location of the object in an image. Which means, like in convolutional neural network, the parameter sharing will be there. Here, artificial neural network, since they have connected each node with every node in the hidden layer, the parameter sharing will be not there. So, to overcome the problem, they are using the convolutional neural network. The convolutional neural network, what will happen here? The initial layers will detect small edges. As we move on to layers, the small parts of the images will be initially detected. As we move on, like little bit bigger parts, and if we combine all these smaller and bigger parts, it will detect the faces here. So basically, it is doing convolutional neural network. I'll explain how it will do. The convolutional neural network will have different types of blocks will be there. So this is the differences between the artificial neural network and convolutional neural network. Artificial neural network will have a input layer, hidden layer, and output layer. So here every node is connected to every node in the hidden layer. The hidden layer nodes will be connected to output layer. So but in convolutional neural network, we are using convolution filters. The convolution filters will be slided entire image. I will explain how they are doing. So these are the building blocks of convolution neural network. So we are having convolution layers, pooling and unpooling layers, stride, padding, and fully connected layers. These are the building blocks involved in the convolution neural networks. What is convolution layers? So for example, if you are having a size 6 cross 6, what it will do means, this is a convolution filter. This convolution filter strided over entire image. For example, this is the edge detection filter, that is vertical edge detection filter. This vertical edge detection filter is applied to this 6 cross 6 image. It will produce us 4 plus 4. So if you slide with a step of 1, you will slide entire image, you are getting 4 plus 4. So how you are defining the size here? That is 6. The virtual size is 6. We are convolving the 3 cross 3. That is 6 minus 3. It will be 3 plus 1 output. That is the output image. That is 4 plus 4. 6 minus 3 plus 1. That is 3 plus 1. We will get 4. So these are the values we are getting. These are the different types of convolution filters. That is a vertical filter. This is the horizontal filter. Horizontal filter will have the horizontal values. Vertical filter will have vertical values. So we are getting the output based on the image size. For example, this is the color image. For example, color image. Color image size is, that is n cross n into 3. 3 is nothing but the RGB value. Since we are discussing about the color image, it will have 3 channels, that is red, green and blue. So if the size is n cross n, if we are having a filter which is the size f cross 3, why? Because we are also adding 3 here, means since it is the color image, the channel should be 3. So we are convolving 3 channels here. So the output will be n minus f plus 1. That is the size of the output image. So what is the slide? That is convolution filter. Convolution filter means we are convolving the filter with entire image. With the entire image. So what is slide? Slide is nothing but while sliding the for example, slide of 1. Slide of 1 means the trig of the one we are convolving and we are shifting one position. We are shifting one position, which means the second will be the second filter will be is coming like this. Again, third will be shifting one position. It will be coming like this. One position we are shifting and we are convolving the entire image. Slide of 2 means we are shifting by 2 positions. First, if we are doing this means we are shifting by 2 and we are convolving. Shifting by 2, we are convolving. Like that. Slide of 2. If it is 1, this is the output image formula. That is, if you are that is n minus f by slide plus 1. N is nothing but vertical size. F is the kernel size. And how many slides we are using? That is 1 or 2. Based on that, we are getting the output image. That is the slide concept. Then we are having padding. Padding is nothing but we will have 2 types of padding, that is valid and same. So if you want to retain the original size, if you want to retain, for example, if it is 8 cross 8, you want to the output image should be 8 cross 8. If you want to retain the original size, we have to add across the zeros, across the boundaries of the image. Why? Because we want to get, this is not 8%, that is 7 plus 7. This is 7 plus 7 actually. So to get original image, we are adding zeros across the boundaries to get the original image. Valid convolution means we are not adding any zeros across the boundaries. So if you are not adding, which means the original size will be 7 plus 7. If you are convolving 5 plus 5 means 7 minus 5, that is 2 plus 1. So getting the output image will be 3. Here also, this is the formula. This is the formula for getting the, if you are having slide that is valid or on valid or safe, we are using this kind of formula. Pooling. We are having different types of pooling will be there. That is max pooling, average pooling. What we are doing here? For example, this is the image. We want to convolve 2 cross 2 filter, which means it will take maximum information in the image. For example, in this, the first will be 10, 11, 9, 11. So if you are doing max pooling information, it will take the maximum value, that is 11. Then 13, 14, 10, 11. The maximum value will be 14. 10, 6, 14, 7. That is maximum value will be 14. So it will extract only the maximum information. So that is max pooling. And average pooling means instead of taking maximum information, it will add all the elements and it will take the average. 10, 11, 9, 7. If you add and divided by 4, if you are getting 9. So it is the average pooling. Unpooling means That is the reverse process. Here we are getting the max pooling. So you want to retain the original image. You cannot retain virtual pixels, but what we'll do, so unpooling means whatever the location, the 11th is there, the 11th position we are replacing the element there, and remaining element will be duplicate of that pixel, 11, 11, 11. 14 will be, we are replacing the same place, and the remaining will be 14. That is unpooling. So, how these when we view the data, so inside the convolution layer, how the model will be training means. For example, if you consider the digit 9, so we are giving so many filters. We call it as feature maps. Feature maps. These feature map means, for example, if you are using 32 feature maps, 32 filters they are using, which means 32 filters they are using. For example, if you are considering loopy patterns in the 9th element, so it will search the wherever the circle, loopy means circle. Wherever the circle is there, for example, this is the loopy pattern kernel filter. This is the loopy filter. It will search as the circle. So that will be highlighted. For example, 6. If you apply a convolution kernel to this 6, it will search the circle and it will highlight this element. And similarly for 8, the circle will be this position. That position will be high. Remaining will be 0. Similarly, 9, 6 will be like this. This is loopy pattern. If it is horizontal or vertical, after detecting loopy pattern, then it will detect for vertical line, that position will be highlighted, and diagonal line, that position will be highlighted. So we are using 3 filters here for detecting these 9. We are using loopy pattern, horizontal and vertical or diagonal filters. So that position will be highlighted in the feature map. So this is the how. So initially, as I told, in convolutional neural network, the initial layers will detect small parts of the image. So when you give the image, the small parts like these horizontal, vertical, diagonal, these parts will be detected in the initial layers. As the layer goes on, it will be combines these smaller parts, and it will bigger parts will be detected, like loopy patterns, vertical patterns, diagonal patterns, and the output combining all these, we are getting the original value. These are the different examples. So this is, for example, this is the image, the animal image. So for eye detector, we have some filters we did it. So if you apply this eye detector to this, that position will be highlighted. If it is, this is a different image. Wherever the eye is there, that will be highlighted in the feature map. Which means they are conforming the eye detector filter to that image. Wherever the small, these are the small parts in the image. So that part will be highlighted. So as the layer moves on, like initially eyes, hand, ears, legs, these are the parts will be highlighted in the initial layers. And as the layer goes on, it will combine and it will make bigger parts, that is head, body. Then if you combine in the next layer, that is the classification stage, if you combine all these bigger parts, you will get the original image. So that will be the predicted image. So in summary, so as I told, the convolutional neural network will have convolution filters, activation function. Here we are using the activation function, that is radio activation function. It is like a sigmoid band. So here the radio activation function is nothing but wherever the negative value will be there, that will be assigned to a 0. If it is more positive value, it will be assigned to a 1. So in collusion, what we are doing, connections partially reduces overfitting. Collusion plus pooling gives location equivalent feature detection. Parameter sharing will be there if you are doing collusion filters. So there is for non-linearity, that is the activation function, it will say yes or no. And pooling is for reducing the dimension, and it will reduces the overfitting and make the model orient towards small distortion variation. So why these are the benefit if you are using convolutional neural network rather than artificial neural networks. So this is the simple model, the simple convolutional neural network model they are using for detecting the input image. So as I told, these are like till now we have discussed building blocks in the convolutional neural network. So using these convolutional neural network blocks, the building blocks, how they are creating these final convolution layers, convolution neural network model. We say that convolution neural network model. For example, in this stage, the input having a size 28 cross 28 cross 1. 1 means what? It is having one channel. That is grayscale image. So when that is a binary image, let's say binary grayscale. So if feed into a model, so we are using 5 cross 5 kernel. We are using 5 cross 5. So if you convert 5 cross 5 into this image, we are getting the image size as 24 cross 24 cross channel. Then we are using max pooling operation. Max pooling operation basically what it will do, it will reduce the dimension. It is like a downsampling operation. So what are the image size is it? 24 cross 24. When you do max pooling by we take cross 2 cross 2, it will reduce us by half. That is 12 cross 12. Then again we are doing 5 cross 5 kernel. So here, as I told, in padding we have two types, same and valid. If we are using here, they are using valid padding. That's why the image resolution, the resolution will be reduces. If you are putting it is same here, the output will be 28 cross 28. It will come 28 cross 28. Why? Because across the boundaries we are adding the zeros there. Automatically it will add the zeros across the boundaries and it will retain the version size. Since they are using valid, that's why the image resolution will be reduced. Same thing, same process will happen, the image reduction, the version size will be reduced here. And after getting some two layers, we are doing flatten, that is from here to here, it will be feature extraction. And final will be, we call as fully connected layer, which means whatever the image we are getting, we are converting the two-dimensional array to one-dimensional array, and we are predicting the outputs. That is we call as classification stage. We call as classification stage. So for doing these medical image processing or any semantic segmentation, the most popular method we are using is the unit architecture. The unit architecture, why they have given name unit architecture means the shape looks like U shape. That's why they have given unit architecture. So what is it is like a encoder and decoder based architectures. Here this is the encoder and decoder architecture. So what we are doing here is initially we will take the input and we will convolve with, we are using some convolution filters. Convolution filter, they call it convolution layers, and after that we are doing max pooling. Again convolution, max pooling, convolution, max pooling. At the end, again they are unpooling. And after doing max pooling, some of the features we are copying from encoder to decoder, that we call as skip connection. And finally, we use a classifier. At the final stage, we are using some classifier like for binary classification, we are using sigmoid. If it is multi-class classification, we are using soft maps. So that is a classifier we are using. Finally, we get segmented out. How unit architecture works means, so this is a unit architecture, virtual unit architecture, virtual paper. This is a virtual paper that is that paper is published in 2015. So the image size is here is 572 plus 572. First, if they convolve, they are using 3 cross 3 convolution filters. They are using 3 cross 3 convolution filters followed by activation function for gradient. So when they do 3 cross 3 convolution filters, the image size is reduces to 570 cross 570. So they are using valid or same padding. They are using valid. Therefore, the image size will be reduces. They are using valid. So what about 64 is there? 64. So this is the original image. This is the convolution filter. They are using 64 here. This is 572. Then the image size is reduced to 576. Is the valid padding. What 64 represents here?
Feature maps.
It is feature maps. Which means for this image they are using 64 filters. They are using 64 filters, which means it will produce 64 feature maps. The 64 filters will be different filters. For example, they have taken horizontal filter, vertical filter, diagonal filter, loopy filter, all kind of filters they are using, and they are producing this.
So is there any way to choose the specific filters based on the application of the data set, what we take?
You are asking about the feature.
The
Whatever
features.
feature.
Programmatically, it is completely abstracted, right?
Yes, ma'am. Actually, convolutional neural network, we don't know. Like in deep learning, that is the black box kind. We are giving the filters. We don't know what kind of features, what kind of filters it is taking. So inside, we don't know what is happening. But usually they will say when you like all kind of filters they will take horizontal, vertical, diagonal. But we cannot specify. I think we cannot specify the filters while doing the training.
Practically, all the filters may not be useful also, or helpful.
Yes, ma'am. That is correct. Otherwise, it is not that mandatory. You can take 64 only. You can reduce to 32. You can reduce to 12, 8, 4, like that.
That is one of the issues with the deep learning where feature selection is automatic.
Yes.
You don't have a control.
What is the main drawback? Like, what is the main difference in machine learning and deep learning is? In machine learning, we are manually giving the features. But deep learning, it is automatically will take the features. That is the main drawback. So 64 feature map will be detected. Again, we are giving the convolution filter here. Again, we are using 64 filters there. It will create 64 feature maps. After that, we are doing max pooling operation. So what unit says that? So when you do convolution filters, when you do the convolution filter, like the image resolution will be reduces as the layer goes on. As the layer goes on means this is the first layer, this is the second layer, and third layer. As the layer goes on, the image resolution will become half. For example, if you are using same padding, for example, if you are using here they have used valid. If you are using same, the 572 cross 572 will become half. That is 284 cross something. It will around 284. It will come 286 or something. It will come 286 cross 286, and here 142, 143, 143 something. So the image resolution will become half, and the feature map will be doubled. Initially we used 64, next 128, next 256, next 51. That is the unit architecture. The unit architecture says that image resolution will be reduced as the layer goes on, and features map will be doubles.
What is
Same
the,
thing.
what is the feature maps? What does it do? How does it get about?
The patterns, as I told you, these filters is nothing but, for example, if you are having a dog image, initially I told you, this is a dog, you will have some patterns like eye, different types. This is the mouth, this is the nose, this is the mouth. When you apply some filters, loopy filters, like for example, circle filter, it will detect only circles. That will use a feature map.
Give us example that 9 that.
Yes, 9. We have given. So it will detect like loopy pattern, horizontal, vertical line, diagonal line. These are the features.
So why are we doing 64 and 64?
64. So we can take any value. It is not mandatory like you can take 64 only. Here they have used 64 filters, which means 64 feature maps, which means they are using 64 filters. They have applied 64 filters to that image. So it will produce automatically, if you apply 64 filters to that like personal image, it will produce the 64 feature maps. That is the 64 feature map. Again they will apply 64 filters, again it will produce the 64 feature map. So this is the unit architecture. And they have used one skip connections, that is they have copied some of the information from encoder to decoder. Why they have done means to retain the version, to get the reconstructed image should be proper. For example, the encoder some features should be copied here, the final output will be little bit more accurate. That's why they have they have copied some of the information from encoder to decoder. Why? Because by doing upsampling, as I told, in unpooling. So if you are having information, for example, 2, 3, 6, 7. So when you do upsampling, it will become 8 cross 8. If you fill 2 here, the remaining element will be 2. We are not getting the original information. For example, this 2 will have some 1, 2, 3, 4. The 0, 1. They are expecting the maximum information here. So the original information will be 1, 1, 0. So here we are getting 2 plus 2. So there is a information loss. So to decode that information, they are copying some of the information from encoder to decoder, so that the reconstructed image will be proper.
Copying some information or all the information?
Some information. They have copied only out of 128, they have copied 64 or something. For example, if you add, this is 250, this is 256, so on 128 features they are copied. So if you upsample this one, you will get 128 here. Here 128. 128 is copied from encoder to here, it will be the 256. This is the another type of segment architecture. This is also 2016 they have published. This is encoder decoder architecture. Instead of skip connection, they have used pooling layers. They have not copied any information from encoder to decoder. So using this concept in my research work, what I have done means I have worked on 3 modalities, that is diagnostic, this is X-ray image and MRI. So in MRI brain tissue segmentations I have done. In teeth segmentation and diagnostic skin lesion. We will have a skin. There are several challenges will happen here in skin. For example, the skin is covered with hair. So illusions will be there, dark corner artifacts will be there. So to remove all these things, some pre-processing I have done. So that will be explained in the next slides. So what I have done means I have used these three modality images, that is some open source data sets. And for example, the ear skin, these are the pre-processing I have done. MRI, this is the pre-processing. And dental, I have not done anything. And I have created one CNN model. So as I explained in unit architecture, like that I have created my own model. I trained on that model and I have segmented the output. So pre-processing means, so as I told, this is a multi-class classification. Basically, I have collected these brain tumor images. I have predicted like 3 or 4 classes like cerebrospinal fluid, gray matter, and white matter. These are the tissues which will helpful for identification of, especially this CSL, Alzheimer's disease. This is the one of the biomarker for Alzheimer's disease. So that's why for segmentation, we have taken 4 classes, and actually the original size of the MRI volume will be 208 cross 176 cross 176. This is the height, width, and this is the depth. Depth means frames. This is the frames. So since this is the uneven size, like 208 cross 176, so I made equal for equal size. At the border, I have added some of the pixels. I have made 256 cross 256. And since why I have made this, I am using some. I am extracting the patches, like 4 uniform patches. If you divide this 256 cross 256, it will become 128 cross 128. So this is the pre-processing step. Actually, this image is feed like I have calculated this 208 cross 176 cross 176 into 256 cross 256. Instead of taking 176, I have taken only 48. Why? Because the consecutive frame space, consecutive slides will be share the same information. Consecutive frames, like neighboring frames will share the same information. To avoid that, with the step of 3 frames I have extracted, it will come 48. So after that, the patches we are divided into 4 uniform patches and given the proposed model, and the test input is given, we will get the predicted outcome. So in the screen, as I told, since it is covered with hair, some morphological operations and imprinting methods are done, and to make the uniform color, I have used the gray color, gray shade algorithm to make it a uniform color. So this is the pre-processing I have done. So usually it will look like this. After pre-process, the hair will be removed and it will be in the same color. And this is the ground truth. They are already given the ground truth image. So as I told, supervised learning will have the label data. Label data is nothing but this is the ground truth. We say the label data also called as ground truth. Initially we know the output value. This is the actual value, actual image. So when you feed these images into a model, it will predict one more image. We will compare both. So how much accuracy is there? That is the way we will basically use the dice score and Jacquard index for comparison. And this is the tooth image. So the main objective of doing like creating this model, like most of the model will take for training the data, will take more computation time, and also it will take like obviously the learnable parameter will be more, and accuracy will be learnable parameter, and it will take more computation complexity. So to make that, I have. So this is the first architecture. This is the first architecture. We have created like it is like a unit architecture. Along with unit architecture, some like version. When I take a version image, I have again downsampled the version image that we got as that is mainly extract the multi-scale discriminant index, multi-discriminating information, and that will be copied in encoder. Here, right side, like just we are taking this one and sample. That is to make the conversion faster. We are doing this and since the 4 classes, softmax class we are using. So this is the one model of paper, and this is the so each model will have one paper. This is another model like I have sent it with global attention. Like step by step, I have written like starting initially I have added this left leg and right leg. Then some attention mechanism added. After that, this is the different model which is having it uses different types of convolution numbers. That is spatial group convolution, and that is also encoder and decoder block. And we'll use all these multi-scale information. We'll predict the output. And this is also a hierarchical multi-scale aggregation method. And this is the architecture. It will take this stuff using convolutional layers. We call it as squeeze layers. Squeeze layers that include 5 models. Mainly, it reduces the computation complexity. So he replace the convolution between one 5 model. The 5 model inside the 5 model will have squeeze layer and expand layer. So it uses 1 cross 1 convolution filters here. So basically, it will reduce the learnable parameter to, and also accuracy will be high in this model. That we call as squeeze and signal. And usually, while doing this kind of experiment, we need GPU. Like we use NVIDIA GeForce RTX, that is 3090. And also, I worked on TensorFlow and value activation function. These are the cost functions. As a binary classification is, we are using these binary cosine tree. If we are using more than 2 classes, the cost function we are using categorical cosine tree. And these are the optimizers. And evaluation metrics, as I told, accuracy, tiles, checkered index basically compares the original with the ground truth. These are the values, and also we have compared the proposed method with different existing algorithms. And these are the results. So when we are doing this research, so first we have to look into, like, first we have to build a small architecture. Then like for example, if you are starting with unit architecture, you can build that unit architecture. Then slowly you can modify that architecture. Like you can replace solution with some other filters, some other like array of 5 models to reduce the computation complexity. Instead of taking 1 cross 3 cross 3, you can use 5 cross 5, 7 cross 7. You can check you can check out all kind of trial and error. Then you can see the results. This is my work, and thank you.
So with this, we conclude the session 2, and we'll break for a lunch, and followed by that, the second presentation of Monica is going to give a basic information on it. We have a wide audience from even mechanical department. So he will be giving one session on all the fundamentals of image processing. Followed by that, again Sam will continue with hands-on session. Okay, hands-on session. As I said, now you know about the advantage of artificial intelligence. Within one talk, okay, everything will be done. But technically, as a teacher, we should know what exactly each and every line does. What is the meaning of that? So initially, you will be doing it in IT, and at the end of the session, you will it's already it's already installed in all the systems, so you can try the systems over here. If you want to use your laptop, also I already sent the recommended email. So we'll take now, and we'll meet as early as possible, probably on this 12:15, so 1 o'clock, so that we can cover more. I don't don't want to miss any. So proper 1 o'clock we'll try. Thank you. Good afternoon, participants. I welcome you for the third session of A1 of So I'm privileged to welcome the guest speaker, Dr. He has completed his full time PhD in analytics, and he also got 100 project experience. I got the PhD. His NTPTC college is started and he is now working in a different company. He's an active over there. So he is actively involved in various students' activities. So usually PDPC starting in Japan and America. So I'm very worried because we have to send it for person and the date of program is not travel option because very keen in that. So I'm very happy that he is not traveling this time to do all the activities. Yes. So that will be thank you. I'm hand over to you.
Am I audible? No. Sorry? Yeah. The mic was
Okay,
Nice.
please be little audible.
Yeah. Okay, good afternoon. As I introduced myself, thanks for inviting me here. Maybe it's afternoon time, and also most of you will be in sleep mode. Okay, I don't want to teach you any buzzwords or some theoretical stuff. Okay. So let me this session I focus on mostly on the application side. So what is mean by let's say why real-time image processing is required? What is the implication? What is the effect you can have it in other domains, like for example telecom or that's the that's what I want to cover here. So there is a each word has its own meaning basically. Okay. So processing, the first one is processing. You process any signal that you have and then to make it as a presentable format. Okay, I think processing perspective, we have shared, I think my previous speaker has shared so many things, algorithms, filters and so on. Okay. I'm not going to teach everything on that. Okay. Do we see any relationship between signal processing and image processing? Any guess? Yes. Because see how image is created. So can anyone tell me which is the oldest real-time image processor? Real-time image processor. Eyes. Thank you, sir. Our eyes is the perfect real-time image processor. Now people are working to mimic our eyes. That's all. The camera was invented because of our eyes. Several things on images invented based on our eye functionality. Okay. They went on deeper into our eyes functionality, everything, how it is working, how it is sensing, and so on. Based on that only, all the algorithms are being developed, all the modeling being developed, everything. Okay. So now, how our eye works? Most of you know that it is sending some signal, and then reflect back, process it, and then visualize it. Okay. Yeah, this is a big man. This is a wall. Something. Okay. So that's how we have to do now. So what is the processing required? See, now I have to send a signal, get back, and then it will be a 2D, 2-dimensional or 3-dimensional image. How many data sets I am going to get? X, Y, or X, Y, Z, and then how I am going to extract those data, how I am going to feed that data, how I am going to process the data, whether I am going to process it as an analog format, for example, as a signal itself, what is the implication, what is the advantage, what is there, and then whether I am going to convert that into a digital data and then process it. So these many things are to be done in any image processing perspective. So now the time is involved, right? For example, I am sending a signal, coming back, process it, convert to some form, do filtering, all that stuff, come up with, for example, and then you will visualize your image. So where exactly is required? Have anyone taken CT scan contrast? CT scan contrast. Quite expensive. MRI? Have you ever heard MRI? Right? Okay. So CT scan contrast. If you take CT scan, they will take minimum 3 hours to process it and then give you the inference. This is what is your problem is. This is what is your problem is. Even X-ray also. Now you just go to any X-ray scan center, they will not give you immediately. You have to check whether they received it properly or not, and so on. Then they will give you the result. Okay. Then when you go to MRI scan, it will take 4-5 hours, right? That is the need for real-time image processing. So now we cannot achieve, like for example, as I said, there are a number of steps involved in between. So how to make it real time? So what kind of technology that we can use, or we can say, we can forecast what the real time image processing. What will be the implication of that? Where will be this real time image processing will be used? For us in India, it's okay. I can wait for 3 hours to get that, for example, CT scan or MRI results. I can wait for it. Okay, but if you are going for an application like URLC, that is remote surgery or remote, for example, remote monitoring. For example, you might have seen that somebody may have a pacemaker, and then these signals will be sent to IoT devices. Then keep on monitoring how your heart is functioning, while you are walking, while you are sleeping, and so on. So now this is about the signal, just a signal. Okay, but it will not be real time, but somehow they can manage to identify this guy is okay, not okay, or not. Okay, but if you tell about the image process, for example, when you take a car, autonomous car. Okay, now what you have to do? You have to take a picture. Radar camera will be there. You will take a picture and visualize which object is that. Whether it is a moving object or a stable object, whether it is harmful or not, whether it is moving like this or like this. You have to make an assumption that how I am going to process it real time, so that if my car is going 100 km speed, 200 km speed, I may not be something. Okay. So without this also, till now the car is working now. For example, in US there is Waymo operator is there. They operate only autonomous cars. Wherever you go in US, most of the cities, Waymo, wherever you just book the car, it will come to you. Whenever you put OTP, then it will open the door, then you will go to the exact parking location. It will not drop you anywhere like ours, wherever you want. So it is working, but how to improve that? How to, like for example, it is a value add. Next is the, so far we have seen about the processing, why processing is required, what is the implication of that. Next is the image processing. Then third one is the medical image processing. So medical image processing is very important because see, most of the in India, most of the deaths are due to clinical errors, especially the test result error. Okay, for example, somebody might not have a heart disease. That turn out, the result will show. Doctors will believe in that. They do not very cross-verify what is their other symptoms and so on. Earlier, they used to ask if they are having heart problem. They will ask, do you have pain in your, below knee or not? And then they will ask you so many questions. Now there is no question. Simply look at the ECG, then blood bill, echo, okay, go for angio. That's all. Okay, my cousins also cardiologist, but still I see so many cases. They don't have time to listen to people. Okay, that's why we are doing the process. Okay, so that's why most of the clinical errors are, most of the medical, the deaths in the medical field are due to these test results. Okay, that is why it is very important that the medical image processing is very much important. The second thing is implication. I can say that, for example, now people are, have you ever anyone gone eye surgery recently? Earlier on, they don't ask you for ECG or anything. Now they ask for everything. ECG, then echo, everything they will ask. Now, why they are asking? See, Now the earlier right that they can the doctor was so well practiced. He understand that if I want surgery for him, the eyes, I know what is the other symptoms are. I can treat. But now there is no maternity to check also. They want all the results, right? The second implication is that they are sending that data to Google. Google like companies, they are going to each and every hospital. They are collecting the data whenever they come for surgery. For example, cataract or any LASIK or any surgery. They are asking all the patients to collect, go for the general physician, complete all these tests, blood tests and all this. So what they are doing is, I might have heard recently in news 6 months back or 8 months back, Google announced that they build an AI model to predict based on the eye disease whether it is a heart patient or not. That kind of classification they have developed a model. How they develop? They collected all these data, huge amount of data, especially already healthcare. They collected all the data from them and from other hospitals also. That okay, they are coming for a contract, then they collect your heart disease, liver function, all the test results. They are correlating all the things and then passing it, coming up with a model saying that okay, just to show your eyes, it will predict the whatever disease you have in your body. That's how they build the model. Okay, so the main problem with that model is that see, in India, you may have a set of diseases common across people. Okay. For example, pressure. How much usually is the normal pressure? 120, 80, something like that, right? But there are some terrain where you can see people always with 170, 120, 170, 100. They are living. But if you go and check, it is that 120, 80 is an average value, not a firm value. But our doctors are well trained to opt for it. If you have 125, they will say give you plus a. That's how we are doing now. So these models, right, they are built based on someone's understanding. Not all of us understand, right? So that is the danger we see in this medical image process. Okay. So that is the implication you can think of. Okay. The second thing is that then you can ask, okay, then why we are going for technology and all? Yeah, of course, it is for fun, some business and so on. But the thing is, what is the pros and cons of that? That's what I am discussing. So the models that you are building, it should be diverse in such a way that it should not give you a wrong result. For example, your person who is in Switzerland, he always used to cold. Okay, he may have so much cholesterol because their foods are different, our foods are different. Okay, so cholesterol. Because you should not make a wrong prediction for them. For example, you might have collected data from them. Then you build a model. The model will say only based on that source, the raw data. So that's how they have to collect all the data. This applies to telecom also. For example, most of the softwares, okay, that telecom, planning software, RM planning softwares are built for Europe and US. They are simply applying here. Doesn't work. That's why they are facing a lot of coverage issues and so on. Okay, so that is the implication. The data should be huge enough to use. When the data set becomes huge, what will happen? The processing times will be happening and computing resources will be huge and the energy consumption also will be huge. You might have seen recent article, right? When you are asking for something, what is that? Okay. You just put your photo, you get that to be some judging. What is it? Ghibli. Okay, sorry. Ghibli. So how much energy they are consuming? ChatGPT reported how much kilowatts they are spending or creating one Ghibli image. Okay, so that is the reality. In medical industry, how to generate root and corners of the image. I might be showing you some of the images. Most of them are open source material, so I'm not going to show any proprietary material or anything, just to show you. So how focused we are. For example, the image for medical image processing really a critical one because, for example, we are going for chest pain. So they can interpret it as a heart disease. They can interpret it as a something like a hit or something like that, or they can interpret it as a bone issues. They can interpret it as a you can say nerve system, many things are there. So how you are going to focus your image processing in what area, depending upon the severity that you have, symptoms that you have. So this focus will be refocused. For example, initially you will get some image. Then you have what you have to do, you have to process some part of it to extract exactly what is the issue that this particular gentleman or woman has. So that is something, first is the initial image processing, then focus image processing. And one of my brother's son undergone CT scan contrast. They took 3 days to come up with a solution, identify what is the issue. But finally it was wrong only. So I said that is a different story. So what they have done is the CT scan you might be knowing. They will put it in that cylindrical or cylindrical image. What will happen? All the antennas are there. They just emit some signal and get back. Based on that, it will identify which area you are focusing and what was the level. And if you are, that's why most of the CT scan they ask you to drink more. Okay? Drink more, and then so that you will see able to see clear image, clear image of the whole body, and also for example, the stomach is filled with the water, right? You can able to visualize each and everything. So how image processing, image is getting generated, because see, each signal will have a different reflection capability. For example, X-ray, right? They will keep one reflector or absorber at the back, white color, right? So what they will do, your bones has a different reflectivity, your tissues have a different reflectivity, your nerves have a different reflectivity, and nerves and all, I don't think it is doable unless in the MRI, in X-ray, bones and tissues. So what, based on reflectivity only, you can identify, okay, you can visualize your, we can say, your body or whichever part you are taking as an example. So the third thing is like real time. So having said all these things, making real time is so much difficult, because, but now the models are being built to make it real time. The question comes, what do you mean by real time? Is it like a millisecond accuracy, or second accuracy, or minute accuracy? That is there, right? Whether we are going to make it as a near real time or exactly real time. The live streaming of images, would that be possible? Hopefully it will be possible, but not for all cases. Because for example, in some of the parts, right, you cannot predict each and everything in a shorter span of time. So that is the implication of that. So what will be the advantage of doing this real-time image processing? For example, you want to diagnose someone remotely. Now you might have seen most of the eye care centers are there. Since they go remote, they don't earlier, right? For the people in village, in my hometown or my city. So village, they used to come for a camp, then they take 50-60 people, they do a free of cost the cataract and all. Okay, but nowadays they are not going for a camp. They are doing just remotely. They connect the machine there, they ask them to sit, and then see, okay, what is going on there in the eyes. Eyes is okay. Main problem is, see, you cannot ask that elderly person is sitting opposite. Just keep your like this. It will be, very often. Many of you might have gone for eye checkup, right? How difficult is that, just keep it like this. So real time means it will take some time to reach. For example, you are doing through internet, right? So it has its own delay, comes back. Then you have to predict what is the issue with that. So now if you are going for real time, the another issue is that what is the real time image for the implication? Whether you are going to do it in a particular system, and then, for example, you are doing a scan, immediately you get the results. Whether you are going to call that as a real time image processing, or whether, for example, some doctor may be sitting in, let's say, Bangalore city, or somewhere in Hyderabad or Mumbai or anywhere, you are undergoing some CT scan over here. Just let know it will be live stream, or you want to live stream this data to that. That is called as real. So it is our perception which way you want to take it. Okay. So there are two things. you are doing it in your system, you are doing, for example, custom built, customized system that is made for real-time image processing, for example, CT scan, MRI scan, to generate the report instantaneously. Okay. So that is one aspect. The other aspect is that real-time streaming of images, processing, streaming, processing, streaming. Okay. But there is a dependency in the network also, right? Because the network will not be, we are going to use the same traditional network, 5G or 6G. So that is why now there is some concept called network slicing. Many of you are aware of networks. EC background or CAC background? EC, CAC. Okay. Maybe communication you might have heard that. There is something called network slicing. So what they do is, if you want to do real-time image processing, or sorry, not even image processing, real-time medication remotely, remote surgery, something like that, they will have separate slices of network, software-defined network. What will happen is, what will implication is that, see, if you are browsing, it will follow certain network path. If it is the real-time applications like, for example, autonomous cars or remote surgery or something like that, it will follow different network path. Okay. That's how we can manage. Then, so as I said sometime back that, so when you are doing image processing, so now we have talked about most of the pros and cons of the real-time image processing. What is image processing? What is the implication of that? Real-time means what? What is it meant as a perception view and so on. Now the processing, when it comes to processing, what kind of algorithms we have? Okay, I think Sir has taught so many algorithms. There are a number of AI-based models also available. The main problem with the AI-based models is that, see, a person who is building the model, for example, if he is a British, he will have different thoughts. His way of thinking will be entirely different. If he is, for example, Indian, who is from south or north or wherever, east or west, so his way of thinking will be different. Okay. So the model, if you are building, right, for example, one of the things I feel it as important, which may not be important for others, right? So that is the main problem with the building models for this process. Okay. The another thing is, with the simple algorithm, can you be able to make out this image processing? No, it is not possible, because you have to undergo all the things. First, you have to filter out what frequency part you are going to focus. You have a LL, LH, HL, HS, all the frequencies, right? You have to filter out what is the part you are going to process. Then you have to do compression. Then you have to do, if you want to modulate or demodulate something, then you have to do that. And whether the image is in the digital format or in analog format, that we need to know. If it is in the analog format, what you have to do? You have to convert that into the digital. Then you have to choose which part of the samples you are going to focus on. Then what you have to do? You have to process it. You cannot process the entire data, because in the image you may have billions of data. For example, especially medical images, for example, CT scan contrast, you have billions of data set you have. So how you are going to focus on which data set you are going to choose? For example, whether you are going to choose arbitrarily or based on some convention, or what convention you are going to use to choose that data or make it processing and then make it real time. Okay. For example, I can make an analogy in telecom, because I am from most of them from telecom and so on. So see, in the telecom, right, you might have seen you are moving. Okay. So they cannot take all your data sets to analyze your position and all. They will take only critical data sets and then make out, okay, this guy may be here or there. That's how. Similarly, it applies here also. Which data set you are going to use, what algorithm you are going to use for that is very critical. Which data set you are going to use. The rest are all, for example, filtering and all, is going to be a common filtering. For example, you can use many filtering already available, well-known filtering available, and in AI model also you might have seen, you might have heard. Have you ever attended any basic AI, foundational AI trainings? If not, you can just go and Google it and then you will attend. So when they start with the least mean square algorithm, steepest descent algorithm, they start with that only. Because how you are converging to a data set. What data set you are going to use, what algorithm you are going to use to compare the data or do the search. Okay. And then the second thing is what kind of image processing you are going to do. Whether you are going to extract the data, or we can say you are going to make an inference, or you are going to classify it, or for example disease classification. Are you going to see what is the application of this image processing? That we need to understand. Whether you are going to do for the classification, whether this person is I think COVID positive, right? Initially, how many days it took? 2-3 days. Initially, when they started with some test, they locally did some test. After 2-3 days, they were saying that okay, he's COVID positive. By the time we have spread it to 100 people. Okay, then they came up with a different model. They came, within the same day we meet. And then they refined the model. We can say model means what I can say the method of diagnosing the COVID. Okay, then they did it in 3 hours. After some time, half an hour, right? So that's how slowly they improved the methodology, right? And then the off rate only they identified that what is the symptoms of that COVID, right? For example, different country people had different symptoms of COVID. For example, I had a COVID, but I did not go to hospital. So I had running nose and then some body pain, no taste, that's all. But my wife had a COVID because someone came to my home and spread it. It's okay, we did not go to hospital at all, but we survived it. Okay, so then my wife had a different setup. Within home, the 4 of us, my 2 kids, all of us had a COVID. All 4 had different varieties of symptoms. So that is in our home itself. For single disease, we had a different symptoms. Why it is happening? Because of the we can say vitamin. Which one? Body nature. So because my body is make more prone to because I for example has some kind of vitamins, or we can say good kind of habits may have my body. Okay, my body will induce some kind of symptoms. The other body may prone to some disease. For example, somebody may be having always they will have running nose. Irrespective of any place they go, they always have running nose. Some people may have always getting cough every month. Some people may get cold every month. Some people may get headache every month. My wife has a migraine and that. So each body has its own capability, or you can say okay, let us take it as a capability. Okay. So depending upon your body's health status, you will react to each disease in a different way. Okay. For example, in the COVID, so the whole my cousin has a hospital. So I stayed there. I used to go every day and meet some people and go. So everybody had a different disease. Just for curiosity, I just go to hospital and see how the disease, the symptoms they have. So they had different symptoms. Most of them, they gave a wrong medicine. For everyone, they gave a medicine. For everyone, most of them got sugar after that. So they are diagnosed. Right? For example, which part of the problem they have. So where they have a COVID plus heart disease or not. Whether they suits suits for rheumatism or made from some other cells, right? So whether it suits or not, because most of the blood cells are right. You have a classification, right? This blood can go for this particular blood group, right? You have a donor and acceptor. So similarly, you will have a different kind of. So most of the people I noticed in that hospital after COVID, they got cured by COVID, but they got sugar, pressure, everything, heart disease. Nowadays, after second, I don't know what is the relation. I don't know. Nowadays, even 25 years old boy is coming with the heart disease. So that is why I am saying the medical processing is too complicated, because each body will react in different fashion. We have to identify how to classify that diseases accurately. That is something that is where the classification algorithm is where the actual tricks is there. Okay. So that's why we are building a model. Right now, Google is working on building a very large language model for this particular thing based on eyes. Just go and show your iris in the scanner. It will scan it and then try to identify this person has this disease, this person has this. So and then the second thing is, like for example, most of the image processing and many processing came because of the difference. Okay, difference. Okay, that also we should acknowledge. For example, we have to say thanks to World War II or whatever technology we have today. But one way it is too horrible. The other way is it opened another door for technology revolution. So most of the medical equipment, they came out from the defense world. For example, MRI, how they invented. They want to detect, for example, they are going for a battlefield, they have to detect who's on the other side, what kind of arms they have. So that kind of analysis only they came up. For example, they came up with the CT, X-ray, MRI, and so on. So what they do is they send some kind of low power signal to them, and then get back and see what kind of arms he has. You can detect. And also in thick forest, where someone is hiding, they have to see what kind of people, how many people are there, what kind of camps they have, and so on. The second thing is the weather prediction. This image processing, once you make it real time, you can able to predict the weather also. For example, lidar-based imaging. Many imaging we have. Lidar-based imaging, you can predict accurately. Now, earlier, right, you cannot predict the storm and all. You cannot predict, I think, in 24 hours in advance or 2-3 days. After that, only we predicted it late. Okay, now we can make good prediction. So these are all interrelated basically. So how we are going to process your data in real time and also the quickly. Main thing is quickly. How quickly is the you can say buzzword we think of, for example, real time means what? Whether it is a near real time means almost millisecond level or second level or minute level or hour level or 30 minutes level. That we need to see. Then I think we can just go the and also many of you might heard that from London, one doctor did surgery called banana in US. You might have seen that. So what they have done, they were just projecting that banana, and then it was live streamed to that doctor. He is sitting in UK. There was a partner project. Okay, what they have done is they have done stitching. Someone peeled a banana and kept it there. Then the doctor used robot to make a stitch to come back. So the implication is that, see, you are saying that
having an impact because of the network issue.
yes, the network issue is there. So that's why in 5G CC there is a concept called network slicing. This slicing means what they do is whenever you are going for this kind of application, real-time application, you will follow different network path. You will not have bottleneck at all. For example, you will not have so many routers, many things. High-speed link will be there. Okay? You will follow, you will reorganize your network for both particular user. You can say you will have a path which is very quick. Depending upon the source and destination, they will make a route map. The transport will make a route map which path it has to follow to take it here. Okay. Then there in that real surgery, the beauty was you are just watching through video. Okay, watching through the video. That okay, I am saying the robot, okay, right arm you take it, but by the time it reaches there, it might have been a different story. He may be seeing that only right arm is moving, but at that time he could have, he is saying right arm is moving, but he was seeing that okay, he was maybe seeing left arm was moving because it was the previous instruction. The next instruction is the move the right arm to put the stitch. Okay, so that delay will do. So why it is delayed? Because see, image means always the memory intensive. Right? When you go for the HD image, in your phone also better. See, when you zoom up to a large scale, what will happen? After 10 days, your phone memory will exhaust. Okay. Now, when you zoom it and then make it accurate, then you can predict easily. So now there is a compromise you have to make. When you are making real-time processing, whether you are going to make up billions of data or trillions of data or metadata, which data you are going to use for the processing. Okay. So in that case, what kind of resolution you are expecting from the raw image? There is a concept called raw image and then the processed image and then enhanced image. Raw image, processed image, enhanced image. So raw image means just whatever you are getting X-ray, just you are getting. Then what you have to do, then you are processing and then you see how you are for example you are taking for the shoulder, how it is looking. Then what you have to do, you have to enhance it and see where exactly the problem is, whether it is due to the joint, whether it is due to the some tissue, as for example, most of the time the tissue will be might be hold around the bones or not. So that kind of enhancing yours. Now, when you talk in terms of the medical image, real-time medical image processing, what kind of resolution you are going to take, right? So whether you are going to take high-resolution image and process it, make a decision immediately, or in that case, you have to compromise with the amount of memory requirement. Then the memory requirement increase means what? The data set, or you can say raw data, has become more and more. Okay. Then now what you have to do? Again, algorithm will be computationally had to be enhanced, and processing will be enhanced. So you have to consume a lot of memory. The third thing is what you can do. You can just take a raw image with the very low resolution. Then the help of image processing and so on, you can enhance your image. That is another way of doing it. So which way you are going to do? You have to compromise between the cost. Second thing is the amount of data you are feeding for the processing, and then what kind of resolution you are looking for. So all these things come into picture when you are doing this real-time image processing. So these things we have to keep it in our mind. So what kind of model we are expecting? For example, when you go for AICTE method, they will say what is the advantage and disadvantage. What is the you have to compare, right? When compared to previous algorithm, what is it? So most of the time what we write, okay, my algorithm can predict very well this particular disease. It can classify disease very well. But input data, what was that? High resolution images. And what was the computation capacity? It was quite intensive. But you have to see that the reviewer will see in perspective of what image he got, what is the computation he used it, what was the cost of the computation, then what was the end result. So we have to compare all these results in order to, for example, cost, computation, and requirement, and then the what kind of classification end result. So these three should be compromised in a way that where we sit, fit our algorithm in these tools. So there are number of algorithms that developed to fit into this, the categories. Like some algorithm may be computational intensive, but it can give very good classification. Some algorithm may be it needs very enhanced data, high resolution data, but it can do good classification. Again, computation is huge. Some algorithm may be require only low resolution data, and then computation is less. But classification can do to the best. For example, 80% of the what the algorithm was used high resolution. So you have to make a compromise between all these two to decide upon which algorithm I am going to use. You have to filter out, for example, three things. One is input data, then computation. The third one is the end results. You have to compare what is it is low, high, or low, high, or you have to make compromise, combination of it, and then where your algorithm fits. That's how we see. Then let's we'll move on to the slides. Okay, so most of the image processing, where we use is the main thing is the time to multiplication, long dual classification, and so on. So now, so these are the number of the, for example, there are those are the input images on top. You see, input images. You are giving as an input for example, cardiac input, and then you have diabetes reduction, sugar level, and then cancer reduction. For example, some reduction you are already done. You are feeding that as an input, and then on the last retinopathy, for example, eyes and so on. So those input data you are giving as an input to the algorithm. What are classifying? Okay, this particular person has a brain tumor reduction, or whether he has thyroid plus sugar, and maybe combination of these will result in thyroid. Because for example, when you have cancer, right, you might be having thyroid related stuff problems, and then fetal localization. So what kind of fetal problem he has when we analyze these things? Okay. Nowadays, when you go for a fetal test, you always check sugar level, pressure level, because when your baby is growing, right, you will have a huge deflection in your sugar level and so on. So how you are going to manage with the diet? Because I have 2 kids, so I know what is the experience I have. Okay, so then we have what is the image segmentation you are going to do out of by analyzing the above data. How you are going to do the image segmentation? For example, how you are categorizing images. For example, based on the above image, how you are going to categorize. Then we have classification. So apart from image processing, this kind of classification, now they are doing kind of radar related stuff, near field radar, and we can say radar. Many things they are going to be using. Microwave itself, they are doing. What they are doing is, instead of converting it as an image itself, what they do, if you have a particular cancer tumor, right, you will have certain reflection capabilities. So see, all these image and all are chemical reactions. When a signal hit on your body or anything, so what is happening? The chemical reaction happening, it is reflect or diffract or absorb. Right? These three phenomena are going to happen. Either it reflect or absorb, or we can say refract. So some of these going to happen. Now what they are doing is, instead of going for giving us an image, put this computationally, what they are doing is, now the different experiment they are trying is that military based, defense based system is what they do. They ask them to stand in front of that microwave machine, microwave sensing, you can say, or you can say sensing machine. So what they do, if you have a tumor, right, they might have got some data to it. For example, those are having already identified tumor patient, they will go and see there and then see what kind of reflection they are getting in that particular tumor area. Then they record it. Okay, this tumor has this much reflectivity. Okay, record it. Then you ask another person who's got cardiac problem or some other problem. Then record the data. Okay, this problem has some kind of reflection. Okay, then record it. Then you build a model on top of it. Then once the model is built, you ask someone else to just go and stand there. Okay, and then it will give real-time prediction that this person has this issues. This can be fixed. Something like that. I think MIT labs also they have tried with this. I think by putting a sensor there, and then they had so many sensors and reflectors and so on. Then finally they did some work. And so why I am saying is, see, when you image processing is becoming complex, real time is not possible. That time what we have to do, George don't want to convert that as an image. Just keep it as a signal itself. You do a signal processing and then detect based on it. That is also another approach to use it. And if you see that, this is what I was doing. So there are a number of models, AI models, you just Google it, you can get it. Okay, number of AI models are available for the image classification, medical image classification, and so on. There are a number of models, so open source models are available. Nowadays, open source models are far better than because see the thing is, the advantage of open source model is you just take it and then you improve your part of it. For example, you identify the issues with that open source model. What is the issue? For example, whether it is problem in the classification, or whether it is a computational intensive, or whether it is the input requirement is huge. You can classify that all the open source models and then see which area you can focus on improving that model. Okay, that's what most of the universities and even industries are doing what they are doing. Just taking the open source model, they will improve according to their requirement. Okay. Then you can see that there are classification is being done, and then you can identify which one you are just this model will have input algorithms. Now what you are doing is same input you are giving to different algorithms. Different algorithms you are giving to 10 different algorithms. Okay. What you are doing is some algorithm may give this guy has a heart disease. Maybe he really have a heart disease. Some person, some algorithm may give it differently. Now you take a voting of which one gives which disease was mostly predicted by all the models. You can just make a judgment that okay, this model, this person has this problem. Okay. It is like, for example, you are reusing all the models for your same data processing. You are giving to all the model at a time and then predicting based on for example, which one is best for which disease he already has. Okay. For example, if 10 model out of 10 models, some model is saying that this guy has heart problem, then you can make out something. So this is to avoid bias towards something. Okay. This is to avoid bias towards something. For example, let me tell you a silly example. Okay. In Japan, right? I think last 2 months back I was there in Japan. Japan, right? When you are crossing, you should stop. Okay. When small kid comes, they will always look for necklace. Whenever crossing is coming. In India, you don't care about it. Most probably will hit and go. Okay, that's it's like we are not. I'm saying we're not comparing. So that is the situation here. That is situation there. Okay, but some places India is far better than there. So something like that. So each culture has a different way of living and so on. Okay, now I am building a model. What I will do? I will build a model based on my own country's behavior, right? For example, you might have seen Mahindra and IAC Bangalore, some startup, they developed a model to the autonomous cars. Right? It knows how to go in gullies, how to go in that, how to take a U-turn. You have to look for someone is coming here, there or not. Suddenly someone will come, suddenly someone will go. Okay, so that's the thing, right? So I will build a model based on my Indian requirements, right? Then someone in Europe, okay, there the population is very limited. The climate is entirely orthogonal to us. Okay. Someone in Japan normally sleep for 6 hours a day. So how to make them, how to make out inference out of them? It is another problem. They may build a model based on their prediction. So now what we do, we compile all the models, keep it as a data, and then see which model is giving. For example, you are just giving input data as same to all the models and see how many models are giving same diseases as common. So that then you can cluster. The other way is that what you can do, depending upon the input data, you can choose between the models. For example, some model may be good in predicting the retina related issues, eye related issues. Some model may be very good in the heart related issues. Some model may be very good in the bone related issues. Now your system model has all these models installed and inbuilt. Now what you can do, you just give the input image. Now one upper layer model, see there will be a you can see that input data, then we'll have there will be a model, upper layer model there. This model is to choose the model, which model I am going to use for this input data, for example. And then input data, then my intent. What is my intent? Whether I have to predict the disease, whether I have to predict the some behavior, heart behavior, whether I have to predict the eye behavior, whether I have to predict the tissue condition, whether I have to predict the bone condition. That is the intent I am giving them. Okay. These two are the inputs. Now this model, what will happen? Bottom of this model, it will have X, Y, Z, A, B. These are the models and bottom up. Now, what is the purpose of this model? Just choose right model for the based on the input data and the intent. Okay. Then, for example, input data is just mostly you can either figure out from the input data itself or based on you have to look for the intent. For example, if you are giving this retina picture and all, you can easily predict this is the eye. I have to predict eye related stuff. But that is the by default. See, if you don't have internet, right, what will happen? You just delete the eye images, so many images. It will easily make out, okay, I want to make model, for example, let's say X is the used for eye related issues. Now, by this model, what will happen? By default, you will select X model for passing this. But not, no. My intent is not that. Okay, I just give you eye data, eye information. Okay, now what I have to do, the intent is predict the heart disease. Now what will happen? There is three models which can predict the heart rate. What it will do, just based on the intent, you can supply the data to these three models and then predict the what kind of heart disease it has. Okay. So here, maybe this also you can have a differentiation. This model may only predict about the, is there any blocking in that nerves or not. Okay, when you have blocking, what will happen to the eye? Well, eye looks like red, right? So some symptoms will be there in the eye. Because see, your blood pumping is very slow. You can make out from the eye system. That's why old doctors get, they always check eyes, and and they predict there and so on. So what they are checking, where and how blood circulation is low. That is what they check. Depending upon that, they make it okay. This guy has this whether it is. So now whether it is a problem or not. The second model may say, okay, he's having a problem with the, some of the heart rate may be shrunk to a small, so you cannot pump up blood beyond the certain range. That's why they go for the artificial support. Some model may say that okay, heart problem is okay, but it is giving indirectly it is raising the BP, sugar level and so on. So that's how you can do this kind of many ways you can implement models. Then you can see that, for example, this is what COVID related stuff. What they have done, they just gave a data set and then just split the data set into multiple data sets. For example, during COVID time, everyone gone to the hospital or don't know. So they might have asked you to take CT scan, blood test first, then COVID test, and then ECG, CT scan, then eye test, some chest test. Chest test. Yeah, chest test. Okay. So these are all the. Okay. So X-ray. Now what it has to do? It has to split the data into the respective models. Right? For example, some will recognize only the eyes and then split and resize it. Okay, resizing means what? For example, you have all frequency data. What I have to do? I want only the low frequency range. I can make out what is the others. I can interpolate or extrapolate this image or whatever it may be. I can do it and then predict others. So I can only extract, or you can say split and extract the data that I require for the processing of the image to get a complete picture. So now we can predict the model is healthy or not healthy. Even though healthy, what kind of supplementary issues he has. So I was okay. 2 times I got COVID, first wave, second wave, no problem. I could survive. So, but that is not the case. Many people can't. So that's why healthy means what kind of classification you can do. For example, healthy, but he can survive for 10 days to see with the normal temperature. If it is critical condition, what will happen? What kind of treatment we have to do? Okay. For most of the time, you see everybody had a remdesivir. Everybody by default 3 lakhs, 5 lakhs package. Okay, whether you like it or not, they will put all the injections. Okay, that's why the way I'm saying is my mother got sugar after that post-COVID trend. That's why I'm saying. So you have to healthy also. You have to see what kind of severity he has, right? So then bacteria, virus, and so on, you can predict. what kind of bacteria? See, that time itself they had a different nuance. So what kind of bacteria they have? Some bacteria was impacting the chest, mainly breathing issues. Some bacteria was taste. Some bacteria was related to symptoms are different because the way the bacteria is behaving in your body. Right? So that's what we have to predict. So real time something like this. So for example, you just feeding a chest image, and then it is you are getting visible or not. You are having this big data. Now what you are doing? You are splitting and then you are shrinking the data to make it real time, then predict, and then we say, okay, just to give a dashboard, okay, just to give the X-ray scan, just feed it, and the background it will work, and then give you, okay, healthy means green, or moderate healthy means orange, yellow, some kind of color we can do as a dashboard, and then show, okay, this is what the classification I can make out from this image. Then we have this kind of data you can see here. You can give large number of X-ray data to predict. For example, these are the guys. For example, in a day, 1,000 patients are being admitted. For example, in that case, what do you do? Just ask them to just take X-ray, and then the software can automatically record all the patient ID and so on. It can record all the images, and then finally you can compile on another algorithm, maybe background it can be ready. Just combine all the, for example, 100 images and make out, okay, these people are COVID positive, these people are not COVID positive. So that kind of, see, you are getting the disastrous image, the situation, that this could help. This kind of algorithms may help. In future, right, the prediction will not be that way. For example, many people lost their life in COVID because of the delay. 2 days also they will not survive because it took 3 days to get the results. Right? By the time they go COVID positive, I heard on my nearby street someone. So they gave it, they were saying that please treat me. They did not touch it. They say that okay, we have to get the results from the. By the time the result came, we already gone to real. So that's how it is. 3 days it took. By the time he already lost his life. So that's how it is. Right? So the prediction should be as quick as possible. And then one scenario I remember when I was child. At a chicken curry, you will not, you feel a lot of pain in these knees and all that. So he was not a medical doctor at all. He was just a practitioner. So he analyzed 10 patients by himself. He just analyzed, okay, this is what is the symptoms of this particular chicken virus. Okay, then he made a combination of drugs, 30 rupees that time, 30 rupees. Whoever comes for that, 30 rupees, just injected that. All are survived. Around 700 people he treated every day. So such an old man, 70, 80 years that time, just like 96 or 99 or sometime, right? So all were survived. 700 people he treated every day. Without going for break, lunch or breakfast, he survived. Those who went for the higher class hospital, out of 10, 2 were lost their life. Because overdose. Which dose? They could not classify which category is this. See, we have to analyze the person's capability and so on. For some of them undergone they gave glucose and so on. Then they re-injected. Some of them did not have an issue. So that's kind of a combination of drugs we have to use. So the classification is very important in that case. So this category can afford to use this kind of drugs. This category can afford to use this kind of drugs. So I am basically allergic to doses. And my wife is used to that. If you ask her to take 10 doses in a day, she takes. But for me, it is allergy. So that's how we see. That's how you have to classify. This guy has this much symptoms, allergy, and so on. You have to give this particular drugs. Something like that. Okay. And then you can see that how based on this learning, you just transfer this learning and then keep it as a pre-trained model. So that whenever a new image comes, instantaneously it can predict and show you this is what is the different result. This is what you can see here. Instantaneously you can see. A person may be taking the X-ray of the other room. The doctor can view here. Okay, this is what is this problem is. Instantaneously. So that's how we can make this medical test. This is another thing like, for example, you are having the lot of models you have, and then you are again reading those images and then maybe voting out of it, and then, or you can say you can choose the right model for the right input data and predict. Then you see here another example is the here you can see the CT data acquisition. You are doing the acquisition. Then what you are doing is your images are coming. See what it does is it will take image by image, area by rotate and then take image, rotate, take image. For example, if you are doing for the abdomen or a kidney or something. So what it does, see back side will take one image, side and so on. So when you are drinking water, you have to have filled water. So it has to, it will be, for example, belly will be full, empty stomach will be full, so that you can take all surrounding images. You keep on feeding an image. Now you have to make out of that 2D images, right? You have to make a 3D image and see what size is your kidney now, right? In this status. So all that stuff, right? So you can make 3D space. Then you can give the operator and 3D images and then process it and then further you do whatever that is. And then these are many techniques like for example first is acquisition, then is the most of the algorithms now are digital compliant. Unless you have digital data, you cannot do any process. Unlike see the main thing is the problem with unlock is that see data sets, number of data required. For example, sine wave. This max, this min, right? How you can represent it in digital? 1, 0, 1. Finished. You can reconstruct the data. You know what reference signal you are using. You can reconstruct the sine wave just by giving 1, 0, 1. That's it. Right. But here, what you have to do? Now take sampling. These 20 samples you have to take, send it, then you have to reconstruct this data on the other side, then you process it. So that is the memory constraint and slow and many data sets are computationally intense. So that's why the analog is not appraisable. So that's why I consider first this visualization. Then you do the calibration. For example, each algorithm, that is a very important topic. Each algorithm requires its own calibration. Okay, otherwise, most of the medical labs has uncalibrated machines. That's why they end up giving wrong results. By undergo, right? They may say you have severe heart disease. Who knows? Because they don't have calibrated image. What do you mean by calibration? Why calibration is important? Any idea? You are going for a shop. Okay? Now he is giving you 1 kg. How you ensure that it is 1 kg? Right, what they do? They must make it 0. Then they will put, for example, they will put something on the top of it and they make it 0, then you put which means you are saying that 1 kg. Here also they do a lot of cheating. The machines is combined in such a way that they will give you 700 grams. I faced one of these. So after all, 1 kg itself, some fruits are here. How about this image? So calibration is how calibration is important is that much important. Let's see. There you are using only maybe 10 rupees, 20 rupees. Here you will lose in lakhs. So that 5 minutes. Then you can see that how you are doing the person. Then here, this is what I was telling you some time back. Okay, for example, some image you already processed it. Now what you have to do, you have to improve some portion of it. Some portion you are seeing that you have to, okay, there is a problem. So the doctor may be guessing, okay, this may be a problem. But now we have to do what you have to do, refocus in that particular area, reconstruct the image, and then see, enhance the image so that you can get it. If you go to some big hospital, right, they will say, simply they will say, go and take another MRI scan. Already you might have paid 50,000. They will say, this image is, this particular area is not covered, go and pay another 50,000 and 50,000. That's all, simply. So this can be avoided by this kind of image. Then you can see the contrast, increasing the contrast of particular portion and reducing and so on. Then, have 10 minutes. Then, okay. So, see, the thing is contrast images, right? So, what kind of contrast you are expecting? from the image. That is very important. Right? For example, some diseases can be predicted based on the very low contrast. So somebody may be having kidney issue. I have seen my so what is happening is the water level is flowing very well. After kidney, it is one point of time it is just slowly coming down. Slowly coming. That's why he has a feeling every time he has to go for washroom. So because it is slowly coming down. 1 liter instead of normal people, for example, 1 liter of waste. Normal people is taking, for example, very 1 ml he has to go. But that the person has to go for every 20 minutes because it is slowly coming. First time 200 ml, 200 ml, 200. Instead of one time, it has to go 5 times. So now what you have to do? You have to contrast this. For example, what kind of contrast you have. For example, that particular area where you have block, you will have a different contrast. For other places, you can have a normal contrast. It's okay. So now you have to focus where is your focus. That's what kind of contrast and what kind of window. Window means you have a whole body. Okay. You have to apply a window that saying that this particular place I want this much contrast. The rest of the place I can wear the normal. Windowing you might have known. Windowing. See in a signal, right? You can take any portion of it. Okay. You can take first half, second half, middle, and so on. So based on that, similarly in the image also, you can take which portion you want to focus. Then you have unlock image. So just now I think I mentioned that what is the disadvantage of unlock image, and then the advantage of digital image processing. So once you convert that as a digital bits, what's in zeros or numbers, right? So what you can do, you can segregate the numbers. You can take only the important. You can choose arbitrarily also, whichever part is required. You can choose it. But in unlock, you have to do continuous. That's the thing we have. And then the digital advantage is that, for example, you can take wide range of acquisition. You can dispatch, you can mingle all the data and then see how you can make out something and then come up with different visualization and so on. And storage also very easy. Transmission also very easy. Now we have become a digital network. Then we have, you can see that this is how you can see the image. Then it is a different sample, and then you can choose which part you want to have. Whether you want this much data, just take it and then process it. Whether you want this much particular data, and process it. Then you have, for example, processed, virtual image. How was it in the processing? You can see here, just this right here, and there, it's not there, and then image processing. How, another thing is that, okay, in Satyasai was there. So what he was saying is that in medical industry, one of the other critical issues that whenever you are taking this image, CT scan, MRI scan, it is very prone to noise. So most of the time, they were saying that, so the person who don't have any disease, who are showing heart attack for many people, they have tested for particular time period, 11:45 to 12:15. That point of time, they were facing issue. Then they analyzed that 11:45 to 12:45 was 12:15 was surgery time. That time they switch on the generator. So the generator noise was making interference with this CT scan or I can say ECG. So they were having this problem. So that is why EMI-EMC we got of EMI-EMC, electromagnetic interference and electromagnetic compatibility. How many of you have done? Just to turn back, you will see FCC, CE, yes, blah 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 blah. So what is it then? You are complying to certain standards. So what will happen is, see, you are having noise in the image. How to filter out? That is also a, see, the thing is, somebody can say by looking at the ECG and echo, oh, okay, this guy has a contract, just make him angiography. After angiography, they realize that there is no problem. That has happened. Okay, so that's why what was the problem was the interference from the external sources. How to filter out that data? That is also very important. See, that is why the calibration comes into picture. And also the lab locality is coming into picture. Nowadays, nobody cares about it. In cities, in big hospitals, nobody cares about it. They just keep it wherever they are convenient, wherever they are cheaper. They are just keeping it. A lot of interferences, many things. They are asking them, they are telling, oh, okay, you want to put some antenna, no problem. They don't know the severity of that interference something goes wrong. That's why they don't allow metal, bone or anything inside because it can easily infect. Or I think you might have heard yesterday in US somebody just entered in the MRI hall. The person who was undergoing MRI died. Because see, that is how the severity is. So that's why what I'm saying is segregating noise is very big problem in the image process. That especially in medical image process.
Sir, any tool is there which can, AI tool which can reduce the noise in the image?
Yeah,
or filtering the
particularly
noise?
I don't know, but there are a number of tools which is specifically designed for the noise. Noise means, in other words, I can say extracting required. You can say extracting required, which means it is, it is avoiding the noise as well as the unwanted. That's also, you can search for these two kind of tools. Then I think there are a number of toolboxes available in MATLAB where you can see the number of AI Copilot is there. But I don't know whether you have a license or not. So Copilot is there where you can do what you can do is you can choose between the models which intent you have. For example, you want only noise reduction and then enhancing means noise reduction or not. So there are a number of tools available. You can just model, you can use that as a base model. Then you can build on top. Maybe I think we just running out of time. So one thing matrix of pixel, then filtering. Filtering. Okay. So filtering is having two kind of filtering. One is we can say spatial domain. Another one is the frequency domain. So spatial domain means what? Frequency domain means what? So you are constructing an image with the low, high, low, high, right? Am I right? Image. Just if you just convert the image to you just write a matter code, convert the image to the raw data, or you can say digital data. What you will get? You will have high frequency on one end, high frequency on the one side. You have matrix, you have 4 quadrant, you have low, high, low, high. Okay. So now frequency domain means you will only analyze in the perspective of frequencies. Which frequency I am going to use? Mostly we will use low frequency. Okay, where you can get all the high frequencies are, you can say harmonics. You can say harmonics, which means product of these two create another harmonics. That's why don't care about harmonics much. High frequency first. You will first focus on low frequency. You can able to reconstruct the image very easily. Then the spatial domain means, that's what I was telling you just some time back. Which part of it you want to enhance spatially? For example, you have a whole just picture, but I want to only see here this particular place. Then the spatial domain filtering. So you have to prepare a spectrum for filtering accordingly. We can say windowing. Which window you are going to choose? That is based on either based on the frequency or based on the spacing. For example, in the whole body image, just COVID time, you saw asked chest pain. They will focus on only this particular area. They will not focus on entire area because where is the fold or something is there or not. That's what they want. The focus was here. So that is the spacing. Then you can see that the AI for human, AI for doctor, AI for image person. Everything is now becoming AI. So I have told you what is the implication of it, what is the pros and cons of it. So how models are built, how different models are built in different indication and so on. So what is the idea is that, see, the high level idea is that you just feed the images continuously, you just keep on classifying in real time, almost real time. Where that, okay, this particular is vaccine development, this is diagnostics, healthcare. So this particular thing is recognition, classification, segmentation, and the kind of picking of which part you will systems. Then you can see that. So these are the you can say the input. Just nowadays of late many countries have already implemented it. I think just gold standard. That's all. Okay, what will happen? You take whichever, so you just give the intent. This particular guy has this cough. Okay, that's all. Just give intent. What it will do, it will take the data, whole data, which is related to cough, or we can say chest pain, or we can say breathing issues. Then it will take all related images and data, Then what it does, give it to the modeling, and then imaging, and then data processing, then real world prediction of the what disease it has. And then you can see here that you can apply on top of it. You can have a chain of models also. For example, initially you are doing the image segregation, then processing, then post processing, enhancement, blah blah blah. You can keep on cascade the models in the serial way or parallel way, whichever way you want to do. So that's what you can see. Then mostly Fourier transform. Fourier transform, FFT is the god of any image processing or any processing. That's all. Thank you. Sure. Hope we have not slipped.
Yeah, I want to thank sir for giving lots of real-time use cases, and especially in the cases when he said that everyone got the same this is the symptom for it. That is really challenging for many topic also that is challenging.
Okay.
So even though it's afternoon session, I believe that making all live lot of attention.
I hope everyone was aware. That is the biggest gift for me.
Thank you once again. Thank you so much. Now we just break for tea, and the talk will start by 3 o'clock because 3 to 4 we are having answers. Okay. Kindly have the tea, snacks, and then we come shortly at 4. Hey, good afternoon again. So we'll start with the final session of day 1. As I said, this session is going to be online. Already I've shared all those Excel file in the WhatsApp group. Hope you have uploaded it. The assignments are pieces you can calculate. Thank you. Thank you.
Hello. Okay. So sir already sent 4 Excel files. So you can download and paste them. So in C folder, like in C folder.
Sir, still 2 more has to come, sir. Another 5 minutes.
5 minutes.
So many.
No, this is basic.
Basic.
I will not start. Just copying the files. So you in your PC the document folder is there. Everyone you can see the document folder. On that you can create something. You can create document folder. On that folder, you can create a folder. The folder name called anything you can give. I have given ML, machine learning or something I have given. So all these Excel, that 4 files will be there for Excel. You can copy into this folder. Copy into this. Four Excel files. CSV file. One more WhatsApp. This 4. You can copy into document folder. So in your PC, the document folder will be there. So inside that document folder, again you can create one folder. That folder name you can give any name. On that you can copy all these 4 Excel CSV files. So here, so already I have created this PC. So in that PC, you will have a document folder here. If you click here, so you will get this custom office templates. So below that you can create one folder. I have created ML code. Inside that ML code you can copy these all the CSV files. All of you copy?
Sir, it is not clear.
After copying, you can come back and here type here search is there. In type here search, here git cmd is there.
Sir, please increase the font, sir.
Send command. Font color. No, you people finding this CMD. That is a command prompt. So in that command prompt, so same.
Even what is it?
That is so you will get if you type git cmd, you will get this command folder, command line, command prompt. You can get command prompt. In type, in search button you will type in search button git cmd will be. Okay. So here what we are doing here means so the Python, we are running the program in Python. We are running the Python program in this is the git. This is the git command line. That is the prompt, command prompt, cmd prompt. So we are running all these. Like for example, if you want to run any libraries, okay. So usually these image processing and machine learning program can do in two platforms. Two platforms. First one is you can work on TensorFlow and PyTorch. These are the two frameworks, like two frameworks. You can work on that. Based on the application, people will choose TensorFlow or PyTorch. Depending on that, they will choose. And for running these programs, we need GPUs. We need GPUs, general processing unit. So we don't have that GPUs. So general processing unit I already told. Like for usually NVIDIA is the version like for example 390 versions will be there. So for installing these CUDA, UDNN, for running, you have to install all these softwares to run these libraries. TensorFlow, PyTorch. Okay, so we are not doing on this. We are simply running on the command prompt. Running on the command prompt using the few libraries. So in this command prompt, first you have to install Jupyter notebook. That is being installed notebook. So already you have opened this command. So ಎಲ್ಲರೂ ಓಪನ್ ಮಾಡಿದ್ಮೇಲೆ ಇದನ್ನ ಟೈಪ್ ಮಾಡಿ pip install command. Pip install notebook. Google Colab. Close Google Colab. Afterwards we will learn that. First we will do it manually. You have to install these libraries. Pip install notebook. Pip install pandas. Seaball. Pip install psychic learn and pip install and dot pip. I'm not going to method this first. So these are the no, you are not added the add class. No. So you have to type in this git cmd prompt. In git cmd prompt, you have to type first pip install notebook. Pip install notebook is for opening the JupyterNet notebook. This library may be used for opening the Jupyter notebook. Python So yeah, they do laptop first Python. They have to install the Python. The version name is 3 point something will be there. So you have to install that. After that, you have to install git bash. You have to type in Google git bash, git bash. you got to install that git bash there. After that, you will get this git command prompt. Matplotlib combined.
I believe Husky is small t. CEO, SCAVO. Skyscraper and Matplotlib. I believe not as useful to all. I believe Husky is like not case sensitive. T is like small t.
Then, so after installing, you have to type Jupyter notebook. You have to type so after installing this, you have to type Jupyter notebook. In CMD, in this hit the CMD only, you have to type Jupyter notebook. After installing all these libraries, you have to type Jupyter notebook. So you will get one window, Jupyter notebook window will appears. So these are the libraries. These pandas mainly used for data visualization. Mainly it will extract the CSV files, send load CSV files by using these pandas. And the CBOR is also data visualization we are using. Scikit-learn is for machine learning algorithms. When you want to extract the, for example, logistic regression, support vector machine, these are the machine learning algorithms. You want to extract these algorithms. All the algorithms will be these scikit-learn. Okay, these are the libraries. Actually, if you want to do some math, like mathematical related analysis, we are using Matplotlib. CBOR is for data visualization, scattering. Jupyter, GUPY. Okay, the window is appeared.
Yes.
So already installed the title I will type Jupyter notebook here. Already installed the libraries. Jupyter notebook. If you type you will get one window in that is internet will get the one window. So on that you have to go to documents and machine learning code. Whatever the files you have installed,
Documents are
starting with the document statement. Document
WhatsApp and Mail, yes.
So those who came late, so before doing this, in document folder, you have to create one more folder that is machine learning code. On that you have to copy all the CSV files.
educational activity. So you have shared the collaboration also with us. As of now, we have only these
Okay, once you have known the language, okay, we'll share again.
No,
Laptop, those who are using laptop, so you have to install before only that Python and files and better to use PC because already installed, sir, already installed on the laptop.
What you have to do, search your laptop, uninstall it, while reinstalling it. In the first page when it lost, there will be checkbox. You have to check it and then install. Otherwise, always like it should be.
Okay, everyone got it? Okay, everyone got it? Okay. So after opening the Jupyter notebook, now we are coding simple linear regression. So in linear regression, what is the linear regression? Is the prediction of values. So we are using function called home prices. Home prices. We are using only one feature, that is area. It is having area size of the area and associated prices. Okay, so 656 is the square area size, and in terms of that will be the price. So we have to train this first. After training, we have to give. If you type any area size of the area, we should predict what is the price of that area. So basically, what we are doing. So these are the data points in Excel sheet. Whatever here is there, let us consider this is the area and this is price. Okay. So for example, the area will start from 500, 750, 1000, 1,250, 1,500. Prices will be starting from 20 lakh, 40 lakh, 60 lakh, 80 lakh. So at 656, which means from here the price will be 39, right? This is the one point. Like that, you will have different points will be there. I am randomly putting the data points here. So these are the inputs. Data points is nothing but these are the inputs. So we want to predict a linear line so that it will minimize the error. Basically, when drawing the line, like this line is nothing but what? Predicted values. These are the original values, that is y. If the predicted value comes here, for example, if you take this is the original value of y, and predicted value will be, for example, it is coming like this, that is y cap. The error will be summation of y minus y cap. This is the original value and this is the predicted value. So we are summing all the data points and we are minimizing the error. Okay, basically we are fitting this line. All the data points should fit this line. Okay, and this is nothing but whatever the distance is there, that is like the line if you draw here, this we call as bias or intercept. Okay, so the line equation, what is the line equation? Line equation will be y is equal to mx plus c. M is nothing but what? Slope. Here x is represents what? It is area. So area is the dependent or independent?
Independent. Independent.
Area is independent variable. Price is dependent variable. Why? Because based on this area only we are predicting the value. So y is dependent, area is independent. C is bias or intercept. So we have a slope. That is also called, basically slope is nothing but coefficients. This is intercepts. Okay. So now we will build a model, linear model, linear regression model, so that all the data from, like if you give unknown area, you should produce price of that area. So after opening this Google, so we will have new here. Set type Python 3, 50 Python 3. It will produces one file. It will produces one file or one file. We can rename it. I can rename like linear regression with one variable. A variable means I am giving one feature. I am giving one feature. So rename it. So for doing this, for training this data, for training part of the RAM, first we have to do. We will have a data, that is x is the data, y is the predicted value. This is the area, it represents area. This represents price. So you have so many values here. So we are training these values. Okay. And one more thing we have to remember, before first what is the first step? First we have to load this data. After that we have to call. These are the steps. First loading the data. Load the data. Then we have to call the algorithm, like logistic regression. That model, whatever the algorithm we are using, we have to call it, and we have to. This is a model. From this model, we are fitting the data. That is model fit. We are fitting the data to this model. After that, we are predicting the values, model, score or something. Okay, these are the steps we are doing in the entire process. If you take any image processing or any classification or regression, first we are loading the data. After that, we are building a model. Then we are fitting that model that is using fit function. After that, evaluation matrix. Using evaluation matrix, we are evaluating the values. So for loading the data, we are using library called pandas. As I told, pandas mainly used for data manipulation and analysis. For that, you can type it import pandas as PD. PD. Okay. Then if you enter, control enter, it will run, and if you press D, it will go to the next cell. For running this command, import pandas as PD, we have to press control and enter. Shift enter. And if you press alphabet B, then the next cell will come. So in here you can see that. Otherwise, if you are not, you can go to this run below run one some command is there, that symbol. Run this cell and advance. You can type it. Okay. And after that, we are importing the libraries, and we are feeding this. We are loading. Using these libraries, we are loading the data. So PD is the data frame. That is the object. So we are reading that CSV file using pt.read CSV. You can give the file name. What is the file name? Home underscore brightness. .csv. Okay, if you type you want to see that CSV file, df.head, if you type it, whatever the files, the CSV file will have the values, it will appear. So now we have loaded the data. After that, as I told, we have to build the model. Already we have taken as we know, the logistic as I told in this case, scikit-learn. The scikit-learn will have the libraries, machine learning algorithms. They have machine learning algorithms. So we can directly invoke this. We have to import this and invoke the library machine learning algorithm. So for that, first First, we have to invoke these libraries from scalar dot linear underscore model import linear integration. So the linear integration model we have invoked. So if you are not getting any other means, it will run successfully. Then we have to create model, that is the variable we are using, model, and type linear regression. And hit enter. So the model is run. Now we have to, the model is built here. Now we want to fit this model using command called model dot fit. So in this we have to invoke the data frame, that is df area square feet, whatever the first name, that is area square feet is there. We have to invoke and invoke the price also. Okay. See here, what we are doing here is, so as I told, X is the training data, Y is the predicted, like price you have to predict, Y is the price, X is the area. So in model fit, we are giving X and Y. X is nothing but that is training data, Y is the output data. It is nothing but output label data. Next, I want to predict the price of 1500. For example, you can use model dot predict. This is a warning. So when you type, I want to predict the price of 1500, the square feet area will be 1500. If you type 1500, it is predicted 95 lakhs. So if you see this Excel sheet, so the 1500 comes around after this 1286, it is labeled in here. So for 1260, the area price, this is the area, the price value will be 83. So when I type the 1500, we are getting 95 lakhs. So it is predicted nearby value. So then you can see that the accuracy of this model will be good. For example, if you type, I want to predict the price when the area is 700. Same, I will copy and paste here. If I give 700, 54 lakhs. It is predicted So if the area is 700, it will come under nearby 656. And the area is 656. The price of the home, price of the home will be 39. So if it is 700, it is predicted 54. So it will be.
It's long, but 700 is already there. Down.
It is nearby values. It is not accurately predicts. A nearby value will predict. It exactly won't predict. Nearby values.
The other is 5.2 lakhs.
So this is the single variable regression. So when you want one more feature, so here area is there. I want to give one more feature like bedroom, like 2 bedroom, 3 bedroom. If you give one more feature, it has to predict price of that home. Okay, to do that, just replace CSV file. We will have another CSV file that is underscore home price, home prices underscore. So otherwise I will copy the code and paste it because we will have only confusions.
So one model we have done that. If you ask for time, the other models we will directly probably show you what to do. The same thing we will start with yours.
So here, same thing. I have invoked the home prices. Here the x, what is the inputs here? You will have two variables. So we want to predict here in one variable, that is mx plus c. This is the area, and this is the slope. So in slope also you can find out. For example, what is the slope value, what is the bias value. So before giving to this, so I will write it model dot coefficients underscore comma model dot intercept. So if you type this, so it will give the model coefficient and what is the bias value as well as slope value it will be.
Any ideal range for that coefficient?
No, it will automatically takes. The coefficient is nothing but what? So we are finding this line, straight line, so that all the data points should be minimized. Like all the virtual, like this data point is nothing but virtual values. If you find the line which all the data points will be fitted, this is the y dash. So basically we are minimizing the error. We are minimizing the error. Based on this line, we are getting slope value. Based on this. So in two variable cases, what is the equation we are getting? We are predicting the price. This is the price. This is the price. And let us take A1, X1, A2, X2 plus B. Here X1 is the area, X2 is the bedroom. This is the bias. A1 and A2 are the coefficients. So we are feeding two features here. So last problem, we have treated only one feature, but the second case, the multiple linear regression, we are feeding two features, x1 and x2, that is area and bed. Based on these features, we are predicting the value. So here, in this example, so after removing CSV file, home prices, so these are the data frame. As I told, there are two features, that is area square feet and bedrooms. And we have to drain these features. We are importing the linear regression. We are making a model. We are doing the model will be fitted here. We are giving the train, the features along with the ground truth. That is price value, y. That is the versional value. This is the versional value. We are feeding x1, x2. This is the predicted value, that is y cap. We are giving x1 and x2, area and bedroom, and ground truth, that is y cap. Sorry, y. Both the feature like input feature and the output label will be giving, and we are training a model. After that, if the area is 1500 and is the bedroom 3, it will predict the value. For example, 1500, which is having 3 bedrooms, and if it is having 2000 square area and bedroom of 2 or 1, that is 2. It will predict the values. Let us check it. twice here. So for having for 1,500 area and bedroom of 3 is having price predicted as 1.6 lakhs. For area 2,000 and bedroom of 2 is predicted 89. So you check it Excel sheet. For 1,600, 325, we are having 80 lakhs. But our prediction is 106. But it is having bedroom of 3. Here, bedroom of 2 is there. You can change the values also. So you can, instead of taking 2, 3, 2, then take it. That will predict accordingly. So this is for linear regression. Now we are going for, as I know, linear regression is predicting the values, and the logistic regression is nothing but we are classifying yes or no, like binary classification. So we go binary classification now. I'll take exactly the program. We need 10 minutes to say. So first I move all the libraries. So the what is the binary classification here is so we are predicting the based on the salaries, we are predicting the based on the person's salary. This is the person's salary. Based on this person's salary, the person is buying the car or not. 0 means he doesn't own the car. 1 means he owns the car. That is 2 labels will be there. 0 or 1 based on these salaries. So initially we have extracted like input partners for extracting the data. Since we are going for training and classification problem, we are using the train test split. So how much we are doing for training and how much we are keeping for testing and validation. And again, in the logistic regression, we are evoking the logistic regression from the Exceler and standard scaler for scaling the data. Like here we are having 2,000, 22,000, 25,000. For standard scaler, it will convert that salary into between values, between the zeros and ones values. And these are the evaluation matrix. There is accuracy. Confusion matrix will be the table, classification report is the precision recall, and these are the evaluation matrix values. So I have invoked the CSV file. This is the data. After invoking, we are plotting the after invoking. Just we are plotting x and y. So these are the data set. These are the data. So you can see that the data will be distributed like the top values ones. Some of the data will be 1 and some of the data will be 0. So we are classifying 0 and 1s. Okay? These are the training data. X is having monthly salary, Y is having owns the car or not. X X is input feature, Y is output, labeled output. We are using single variable class logistic regression. Only one feature and only two classes like zeros or ones. After scattering, we are calling a model. X test. So we are basically splitting. So in this train test split is there. We are calling input feature, output label, test size of 0.3, which means the training data it will take 70%, testing size will be 30%. Random state you can give any values, it will randomly take the data samples. And we are calling the model. After calling the model, it will run. Then after that, we are fitting the model. And predicting the score. So the score will be 88%, the accuracy. The score is nothing but accuracy. Accuracy also you can do all the do all these things. X test will have, this is the data we are having, is the for testing it is taking this much. And Y prediction, so I can like test data and there are 10 test data will be there. For 10 test data, it is predicted values 1010. These are the predicted values. These are the predicted values. This is the test values. So this is the test values, which means we are giving the testing these values and predicted values. You see that only one variable is not matching. Here the third 1, 2, 3, 4, 5, 6, 7. 7 element is one here. That is the actual data, but it is predicted 0 here. The actual data is 1 here. So it is predicted 0 here. So out of 9, it is predicted 8. Correctly, it is predicted 8. So accuracy is nothing but 8 by 9. Prediction, the right prediction by total prediction values, total test values. So this is the single variable logistic regression. Now we have, and also we can have this. You can do classification report. You can make it like precision report. You can find out. So if you type this, you can report classification report. Classification report from the STL matrix. So if you do Y test with Y prediction, if you do that, it will show the precision recovery from two values. Precision is nothing but what? So precision is precision out of all predicted values. Out of all predicted values, how many are correct? This recall is refers to the ground truth. Out of all ground truth values, how many is corrected? Correct prediction. Prediction is nothing but it refers to the prediction. Prediction for prediction. The recall is for ground truth. It will refers to the ground truth. Precision refers to the prediction. So 0 class, the precision value will be 0.83. Recall will be 1. The first score is nothing but it is the harmonic mean of precision and recall. This is the accuracy is 89%. It is so for last we discussed multiple linear regression, logistic regression, multi-class classification. So in multi-class classification, I will directly write down the coding. I will share all this code. You can learn.
Yes, sir. Yes. We will do exercise.
So in this cascader, we will have a data called data set. Already we inbuilt the data set called IRIS. So IRIS will have 3 classes. We are categorized. This is the IRIS element. It represents. It is having the data set having the flowers. There are 3 kinds of flowers. The first one is setosa, versicolor, and virginia. There are 3 types of color, 3 types of flowers. So each flowers will have some features. These are the features based on sepal length, width, petal width. Based on length and width, we have to classify. It can be setosa, versicolor, or virginica. 3 classes will be there. So after loading this data, so here you can see that based on length, the sepal length, width, so what is the target value? 0, 1, 2, like it is 3 classes. It uses 3 classes means 0, 1, and 2.
Again.
See here. So based on sample width, there are 3 kinds of colors: blue, red, and green. So 0 represents setosa, 1 represents so setosa is 1, virginica is. Based on colors, they have classified 3 classes here. So on this kind of distribution, after data visualization, we are going for training. Same we are doing here. For training, what we are doing here, we are looking the function. X train, X test, Y train, Y test. So X train and X test, Y train, Y test. We will have, we are training both. Input features are nothing but what? Sepals, sepal length, sepal width, petal length, sepal width, petal width. These are the X train and X test. Y train and Y test will be classes. So these are the input features: sepal length, sepal width, petal length, petal width. These are the input features. The output label will be 0, 1, or 2. That is the class. That is the target. 0, 1, 2. There are 150 images will be there. 50 setosa, 50 virginica, 50 versicolor. There are uniformly distributed. And we have run the logistic regression model, and we have to fit this data for after presenting the data, we are calling the score, that is X test, Y test, and Y predictor, we are predicting the model. These are the classification method, precision recall for 3 classes. There are 3 classes will be there, 0, 1, 2, 0, Setosa, 1 is Virginica, another one is versicolor. There are 3 classes. For that, this is the precision value, recall and F1 score. This is the 98% will be the accuracy. And finally, these are drawn in the confusion matrix. So this is the confusion matrix. It is the graph between true labels versus predicted labels. True labels, usually there are for testing 30% of the data we have taken. So out of 30%, the Setosa, this is the 0 plus. If the diagonally, if all the values will be there, then predicted accurately. It means it is predicted accurately. So only one item will be, it is not predicted properly. That is Virginica. But it will be the truth label will be the versicolor, but it is predicted Virginica. For this versicolor, 15 is predicted correctly. For Setosa, the 15 is predicted. Actually, it will be Setosa. It is also predicted Setosa. So it is predicted as 15 values predicted correctly. Here also 15. Here 14 because it is strongly predicted one item. Okay. So this is for multi-class regression problem using logistic algorithm. So I will share these code. I will share the code to sir. Sir will distribute you along with the CSV files. So if any doubt, you can ask me anytime.
Thank you for such a great session. So from right now morning till evening, we'll start our winters and it was good answer session. And I feel that it was good for any tomorrow's session we will start with data sets. The morning we will start with fundamentals of Python. It will be completely answer session. And after session we are doing a practice on real-time data set. Can we share the data in our stream? Can we convert it? So we start very complete. And I like to call person for the control speech on it.
And one more thing, you can do all these things in Collab also. So nowadays Collab is having the chat GPT. If you type Gemini AI is there. If you type like code for IRIS data set needs, it will present all the code and it will execute. So you can directly do it in Collab also. But if you are doing that, you won't learn this concept. Basically, you will not. Okay, thank you.
Good evening, everyone. As we come to the conclusion of the session, on behalf of the organizing committee, I would like to take this opportunity to extend our heartfelt gratitude to all who made the session of the workshop a grand success. First and foremost, I would like to thank our esteemed business persons, Dr. Namrata sir and Dr. P. Histopathology sir for their valuable insights session. Your expertise knowledge is very useful, so thank you for the sessions that you have delivered. Finally, I would thank you to all the participants for your active involvement and enthusiasm throughout the day. We look forward for your continuous participation in the upcoming sessions. Thank you all. Have a great day.